Welcome to our class CSE 104. If you missed the first three, 101, 102, and 103, that will not be necessary. It might be advisable if you want to take those, but we're going to take right up with where we left off. We're covering my seminar that is normally 15 hours, and we're going through at a snail's pace, covering all the details that I always feel pressed to leave out. Things I always wanted to say but never had a chance to. This is my opportunity here in this class. We're doing this for the sake of my son Eric. It started off just going to be me keeping Eric up to date on the research that I do, because I'm always adding new material, and he's out traveling and speaking, and I'm out traveling and speaking. So ended up a lot of people want to hear about this. So this is what this is, CSE 104. We're covering what's in the middle of, actually near the beginning of our videotape number 6 of our series. And we're dealing now with what about the Ice Age. At the end, the last class from CSE 103 was the beginning of this session on the Ice Age. So you need to catch up just a few things here. Bring us up to speed if you're only taking this class. We're talking about, what about the Ice Age? The textbooks in school will tell the kids and show pictures how that the ice came down as far as, Kansas City, Missouri, down into, mid to southern Illinois. Was there an Ice Age? I don't think there's much question that yes, there was an Ice Age. If you look at this map, they show the Wisconsin glaciation, the Illinoisan glaciation, Kansas and Nebraska. They'll say there were 4 different ice ages. People have argued about this for years, how many ice ages there were, because as ice goes scooting across the countryside, it scours it, it can scour it down to bare rock. Pushes all the soil out of the way, it doesn't always do that. And when the ice melts back, there's nothing left but solid rock basin where it was. As it pushes along, the ice, like a big bulldozer, will push up a pile of rocks in front of it. Remember when we were in Aunt Lynn's in Mount St. Helens and Mount Rainier? There are what they call moraines all around that region. As the rocks will pile up in front of it, and then when the ice melts back, it leaves this huge pile of rocks. Sometimes they're hundreds of feet high, these piles of rocks, and sometimes they're miles long. All across Illinois and Iowa, you can see the lines on this map here. These are actually moraines. At the end, if it's pushing it along in front of it and then the ice melts back and it disappears, the pile of rocks in front is called a terminal moraine, terminal where it stopped, okay? Usually, after a few hundred years, dirt blows in and pretty soon you can't see the rocks anymore. It's all, becomes just a big mound. And people build houses on it, and their houses, cities built on top of moraines. But if you dig down in 10, 15 feet, you'll start hitting rocks. And sometimes huge rocks, half as big as this house. These monstrous rocks are all pushed in front of this ice. Very frequently, these rocks will have scratches on them where they've been dragged across another rock. Sometimes the ice will push a big boulder for miles and leave behind a scratch, 50 feet wide and 20 feet deep, a scratch in solid rock. If you ever get up near Detroit, there's an island just off into the Lake Erie called Kelly's Island that is loaded with these scratches. You got to take a little boat to get out there. Loaded with these scratches from obvious signs of what's called glaciation. Moving ice leaves behind distinctive characteristics. I don't think there are very many people on the creation or evolution side that would argue this point. Yes, there was an ice age. There was ice all the way down to Kansas City, Missouri. The question is, when did it happen? Now, as the ice pushes, it leaves in front of it a terminal moraine. On the sides of it, they're called lateral moraines. Piles of rocks on the side. Remember when we went out there to Washington, we saw as the ice is bulldozing its way down real slowly down the valley, rocks kind of automatically go to the middle. If you ever look at a glacier, you'll see a streak of rocks right down the middle of it. It's just by the way it moves. The ice in the center is moving a little faster than the ice at the sides because it has friction against the sides and not as much friction in the middle. Ice flows sort of like plastic, real slowly flowing. It can move real fast. There have been times where glaciers have been seen to move 100 yards in a few days. But normally it's real slow. When we climbed on Mount Rainier, there were 13 glaciers on that mountain. As the ice slides down, it's going real slow. As it goes over hills and down into valleys, cracks open up and then close up. If you ever get a chance to see a time-lapse photography of this glacier, you see these huge cracks open up and then they close up, and it's just amazing to watch over, or they can take 6 months and compress it into 5 minutes for you, Those cracks are 200 feet deep, this wide, maybe this wide, 200 feet deep. Sometimes you get a crack, say, this wide and 150 or 200 feet deep, and it snows real heavy, and it's enough snow that you can't see the crack. There's 6 inches of snow. You're walking along, disappear down into what they call a crevasse. As we were climbing Mount Rainier, the guides take us up there, and you take these routes to get up to the top of Mount Rainier. These guys are checking carefully for these crevasses, and everybody's all roped together, and you're spread out, 20 or 30 feet between each person. In case somebody falls into a crevasse, the rest of you, dig in, and his rope goes tight, and then you can pull him back up. But it's extremely dangerous with these cracks in the glaciers. Who cares? Anyway, yes, there's no question the Earth had glaciation effects. As the ice melts back then, it leaves behind very distinctive features. For one thing, a mile of ice is pretty heavy. It presses down on the ground, and once it's gone, the ground actually lifts back up, sometimes many feet. It is estimated that if all the ice at the South Pole were to disappear, Antarctica would lift up probably 2,000 feet. Just the weight would be gone. I mean, if we parked a freight train in our yard, it would dent the ground down a little ways. Or what if we parked a mile of ice? What a gallon of water weighs. Imagine a mile of it. As the ground lifts up, it's called isostatic rebound. The ground lifts up as the pressure is gone. As it melts back, especially across places like Wisconsin and Minnesota, it left behind thousands and thousands of lakes. Have you spoken in Minnesota? I've preached a dozen times in Minnesota. Yeah. They call it the land of 10,000 lakes and 20 billion mosquitoes, because most of these lakes are pretty shallow. It's places where the ice melted back, the ground would lift up unevenly, and sometimes just places are just trapped. Or if the ground isn't quite even and it rains, the water's got nowhere to go, it's going to fill in a puddle. So more like giant mud puddles, because it's pretty flat up there. So yes, there was an ice age. The question is, when was it? And how many were there? Creationists generally fall into 2 camps on this ice age question. I believe the evidence indicates, and we'll cover this, my theory on this in this class, that the ice age caused the flood, and then probably lasted for 200 years after the flood. But that's what started the flood. The other group says, oh no, the flood started the ice age. And I always ask them, well then what started the flood? Well, we don't know. Okay, I don't either, but I think the theory that we're about to share with you, called the Hovind theory, makes as much sense as any I've heard, and it's a combination of many other people's theories. It's nothing original with me. So I don't think there's any argument. Yes, there was an ice age. The question is, when was it? If you took enough water out of the oceans to freeze and cover the North Pole clear down to Kansas City, with a mile-thick layer of ice, that would lower the oceans by hundreds of feet. Just common sense. You take all that water out, freeze it, stick it on the poles. The oceans are much lower, which makes the continents much bigger.
Do we know much about Canada, and does it show the same effect?
Canada shows effects of ice age almost everywhere. Matter of fact, you notice around Denver, Colorado, you can see there's a blue spot on this map. If it's on the previous map, it doesn't show. It's interesting, when they dug into some of the mountains in Denver I think it was for NORAD, I don't remember the story now, maybe it was just a gold mine, the ground is still frozen when you go way down inside. Really strange. Something happened. Mom and I were in Alaska when I was preaching up there about 1.5 years ago, and we went on a little cruise boat for a couple hours out to see the Portage Glacier, where the ice, when it reaches the edge, it breaks off, Sometimes big chunks break off, sometimes little chunks break off. One danger is when the ice breaks off, everybody's standing there watching, all of a sudden, boom, drops down into the water. Well, what happens to the water? Whew, big wave, okay, swamps the boat and everything else can happen. Plus, sometimes the boat will go out there and hit these ice, just like the Titanic. I mean, that's what sunk it, These are smaller icebergs generally, but sometimes huge ones break off. Icebergs, big ones, have been seen floating around for 5 years before they melt. There has been serious talk of getting icebergs and dragging them down with boats to water the Sahara Desert, or to water some of the Arab countries. They got nothing to do with our money. They make all the money from that oil, so let's get a bunch of boats and drag an iceberg down here. Let it melt. It would be fresh water. Anyway, Mom and I are on this little cruise boat out, going seeing the Portage Glacier, and I'm up on the deck talking to this guy standing there. We're watching the icebergs. The process when they break off, it's called calving, like a cow has a calf. Icebergs have a calf. Glaciers have a calf called an iceberg. So we're watching these chunks break off, and it's such an awesome sound, and you got to see it to understand it. And I asked the guy, I said, what do you do for a living? He said, well, I work in the oil field up in Barrow, Alaska. Now, Barrow, Alaska is way at the top of Alaska. There is nothing there, not a tree, hardly a blade of grass. I mean, just nothing. It's way inside the Arctic Circle, so they will get, several months of pure darkness, and during the summertime, several months of 24-hour sunlight. Okay. I said, you work in the oil well, huh? I said, do you ever find anything unusual when you drill? He said, man, we find the strangest things. He said, just 2 weeks ago, the guys were drilling down for an oil well. They drilled through 1,000 feet of solid frozen ground called permafrost, permanently frozen. The top few inches thaws out in the summer, but then everything underneath is frozen, permafrost. He said, here we are drilling down 1,000 feet, and they started bringing up pieces of wood. And so they started saving the pieces of wood as they brought them out, because they always check and see what they're drilling through. They save the pieces and try to reassemble the core on shore, on land, so that they can tell what formation, are they going through sandstone or limestone or shale, or what are they drilling through. He said, we began putting this together. We drilled straight through a tree that was standing up, and it was 300 feet tall. Well, did you ever get up and see the redwoods or sequoias when you were out in California? Okay. The tallest tree in the world today that's known is the General Sherman tree in north of San Francisco in the redwood forest. I think it's 320 feet. That's the world's tallest tree, somewhere close to that. You get up to Barrow, Alaska, there are no trees, nothing. I mean, it's just like a desert almost, okay? Here they are, 1,000 feet underground, and drilled straight through a 300-foot tall tree standing up. Now, just simple statistics would tell you they probably didn't hit the biggest one. I mean, they might have, but the chances are pretty slim. Several times I've talked to people who work in the oil well up there. One guy gave me this years ago. Very few people I've let see this, and even fewer people touch it. This is some of the frozen wood that was brought up from 1,000 feet below the ground in Barrow, Alaska. It is extremely fragile. Every time you touch it, you lose pieces of it. But I'm going to let you guys hold a piece of freeze-dried wood. Eric, if you'll get this and pass it around, it'll crumble like powder if you just bump it. He said, Mr. Hovind, we were bringing up frozen wood, and of course then it thawed out in the warm temperature. He said, it's freeze-dried. Here, I got some for you. That is freeze-dried wood from 1,000 feet below the surface in Barrow, Alaska. He said, we drilled down 1,000 feet, and then we drilled through a layer of wood, frozen wood, several hundred feet thick. Well, what happened? Something was different up there at some time in the past, okay? The question is, when was it? Now, to the evolutionist, of course, well, this was millions and millions of years ago, and the continents are moving around, and the North Pole used to be at the equator and had a big force, and it slowly drifted north and it froze. Well, maybe so, but I don't think so, okay? I think there's a much more logical theory. That is actual freeze-dried wood from 1,000 feet under the ground in Barrow, Alaska. So this well driller said, yeah, we drilled the same thing. He said, we drilled straight through the top of a tree, 300 feet. First of all, because of the angle of the earth, it gets very little sunlight. The further north you go, the slower trees grow.
That's the
shorter growing season. I was on the airplane yesterday coming back from wherever I was, and I sat next to a guy who works in paper mills. He makes the machinery for paper mills. And I've toured many paper mills. I toured one in Port St. Joe down here. And I've talked I sit by a lot of people on the airplane who are in paper industry, because there's a lot of that around here. And I always talk to everybody I sit by on the plane, or try to. And paper down here, you can plant a tree in Florida, and it'll be big enough to cut to harvest in 30 years. I talked to a guy in Canada who worked in the paper mill. He said, yeah, it takes 60 years to get trees up to harvesting height here. They grow slower, a shorter season. The further north you go, the more this becomes a problem. When you get up into central Alaska or further north, I mean, there's incredible trees in southern Alaska. But the further north you go, the shorter the trees get. Until you get up close to the north slope of Alaska, the trees get about 1 inch tall. They grow up and they grow out like a bush. They spread out. They just, because the sun never gets up very high. The sun is always, you know, just right at the equator, or right at the horizon, you know. And the sun comes up over here, and goes down over here. When Mom and I were up there, it was so neat watching the moon, you know, because, you know, the moon would go up and go down. It really never did get over your head, you know. And it's really strange. But anyway, this trees get about yay tall. And they spread out more like a bush because they can absorb more sunlight. Well, how do you get a 300-foot tall tree at the North Pole? Very few people would argue with the fact that something was different at some time on the Earth's surface, because there are enormous trees near the North Pole. At the South Pole, you find the same thing. Admiral Byrd, one of the first guys, maybe the first guy, I don't remember now, to get to the South Pole, back 1927 or something like that, he reported seeing frozen palm leaves, palm fronds, under the ice near the South Pole. Well, there's a few problems with this, okay? There are no trees growing in Antarctica. Nothing. Especially not palm trees. Okay? We are in Pensacola, 30 degrees north of the equator. We have a hard time keeping palm trees alive up here. Really, further south, they do better. 30 degrees, you go up another 50, 100 miles, really hard. It freezes, kills them. That's 30 degrees from the equator. We're talking South Pole, palm leaves. Okay, well, you look at the evidence. It's a fact. These things are found. North Pole and South Pole have evidence of tropical vegetation. What happened? How did it get there? Now, there's numerous theories about that. The continents are drifting. Okay, it used to be tropical, and Antarctica used to be up here, and it drifted south. Maybe so. Okay, that is one theory, and that's the standard textbook theory.
I've heard that the ice built up on the poles, and then it just got so heavy that, it tipped it over. You know, tipped the whole Earth's crust over.
Slid the crust of the Earth. That's what. And see, all of these things are theories that I think certainly worthy of investigation. But we'll give you the Hovind theory, what I think happened. What froze the mammoths? Mammoths are big, huge, hairy, hippie elephants, frozen, some of them standing up. And actually, very few have been found frozen in the standing position. I think about 50 or so, at least that have been researched. Eskimos find them all the time, and they don't care.
Do they eat the meat?
I don't know if Eskimos eat the meat or not. Hans Koopman in Canada, I stayed at his house when I preached up there in Waterloo. His dad worked up on the north slope of Alaska, and his dad said he ate mammoth meat. They found a frozen mammoth, took a chainsaw and cut slabs of meat off with a chainsaw. It's frozen solid. Thawed it out, cooked it, and ate it. According to Hans, his dad said, well, it tasted like it had been in the freezer too long. Well, maybe because it has. You know, it's been in there a while. But there have been reports of a lot of people will feed that mammoth meat to their dogs, no problem. You know, dogs have a much stronger digestive system. But there have been people who have eaten it. At least I stayed with a guy who said his dad did, and I have no reason to doubt him. Okay, the guy's a good Christian. This is the Beresovka mammoth, one of the first ones actually researched. Now, for centuries, it was known about these mammoths up there. And sometimes you get a very warm summer, and they melt. The ice melts a little further than normal, and so these mammoths, you know, are exposed. When all kinds of theories existed down through history about what these mammoths were. Some people used to teach that they were giant animals that lived underground, like moles, and they dig tunnels, and then they come up, and if they see the sunlight, they die. Well, because the only ones you see on the surface are dead. Well, I suppose that's possible, but I don't think so. Okay, I don't think the mammoths are digging holes in the ground. Kind of tough to dig a hole. Some people teach that the mammoths are designed for cold weather. Well, there are many problems. If you get Walt Brown's book in the beginning, he lists a whole list of problems why the mammoth cannot be a cold weather animal. Just because it had 30-inch long hair doesn't mean it's designed for cold weather. Many animals in the jungle have long hair. If the mammoths lived up where it's cold, an elephant today will eat 500 pounds a day. Where's he going to get 500 pounds of vegetation up there? If he's got to scrape the snow out of the way certificate to it. His tusks ought to show wear marks from scraping the snow. They don't. The wear marks there are no wear marks on the tusks that I'm aware of, none significant anyway. So they weren't scraping snow out of the way to get to the stuff underneath. Like a deer, you know, will use his antlers and brush away everything and get to the grass underneath. There just simply isn't enough vegetation up there now to support these mammoths. In 1 year, my understanding is they used to go up and get just the tusks to sell for ivory. Ivory used to be what they used to make keys on piano. That's why they say he's going to tickle the ivory. You know, it's not ivory anymore, it's plastic, but it still sounds better to tickle the ivory than tickle the plastic. And ivory was made for all sorts of jewelry and everything like that. They would go up and get these tusks because they're this big around and 12 feet long, solid ivory, worth a fortune. You could spend all year hunting around and find 2 of them and pay for your year's salary, you know. So they find these mammoth tusks. In 1 year, my understanding is they took out 20,000 pairs of tusks. Most people estimate that probably around the polar region, 5 million mammoths perished. Now, some good friends of mine, like at ICR and groups like that, they think the mammoths froze after the flood. Well, I have a very serious objection to that.
How are you going to get 5 million?
Yeah, there's only 2 mammoths on the ark. It takes a while to get more mammoths, you know, and it would take a long time to get 5 million of them. Okay, you figure they're pregnant for 2 years, at least if they're like an elephant. Elephant's pregnant for 2 years, so this is a long, slow process, getting 5 million of them. And then the other problems are they suffocated. The ones that are able to be investigated, they didn't drown, they suffocated. Get the air on here, would you, Becky? You know, flip that air conditioner over. These red dots on the map indicate where frozen mammoths have been found. The yellow dots indicate where frozen rhinoceros have been found. Frozen woolly rhinoceros. Now, if you look right at the number 140 degree mark there, it goes right through the islands called the New Siberian Islands. On the New Siberian Islands, there have been reports that there are so many animals frozen up there. You can hardly touch the ground when you walk. You're always walking on frozen animals or frozen bones. Frozen bobcat, frozen lynx, camel. I can't document now where I read it, but I know I read it. I'll have to go back and find out where now, because somebody will question me on it. But they found a frozen camel, or the skeleton of a camel. I think it was dried out and dissolved enough, decayed enough. 15 feet tall. First place, camels don't get 15 feet tall. Secondly, they don't live near the North Pole. What would a camel do up at the North Pole? Something was different. Now, why? What happened? We're going to try to explain that here. What froze the mammoths? So here's the things we need to consider. They're frozen, some of them standing up. Not all of them. A few are frozen standing. All you need is one, really, to bring up the question of how did this happen. There's undigested food in their mouth and stomach. Now, some people teach that there's undigested buttercups. There have been reports about that, and the skeptics will jump all over that and say, oh, no, they didn't find buttercups. My understanding is they found buttercup seeds, and there have been all kinds of arguments of when these mammoths died because they analyze what's found in their stomach and what time of year does that grow. If they find buttercup seeds, well, when do buttercups produce seeds? It's only a certain time of the year. Buttercup's a little flower. So by checking what's in their stomach, and some of it in their teeth still have grass, they didn't even finish swallowing their last bite. And they froze. They're not all found this way, but a few have been, okay? They died of suffocation. And there are numerous different ways that they can tell they died of suffocation. Walt Brown has a great section on that in his book. You ought to read that technical section on what happened to the mammoths. Now, his theory is slightly different than mine. Same general concept, but a little bit different idea of what happened to the mammoths. The small ice crystals in the blood indicate they probably froze in less than 5 hours. If ice freezes real slowly, the crystals grow big. If you take water and freeze it real fast, the crystals are very tiny. Like when you make rock candy. I don't know if we never did that, did we, growing up? You take sugar and put it in water and boil it. And as you keep it boiling and boiling, you just keep adding sugar until it won't dissolve anymore. The hotter you get it, the more sugar it will absorb. It'll go way beyond the saturation point. cold water won't dissolve much sugar. That's why if you make iced tea and then add the sugar, it falls to the bottom. It won't absorb it. But if you add the sugar while you're boiling the tea, like the people in the South know how to do, how to make the real sweet tea. Them Yankees don't know how to make it, stuff up there. They add the sugar later. No wonder it tastes terrible. But add the sugar while you're boiling it. You can take water and boil it and just keep adding sugar. And if you see it collecting on the bottom, raise the temperature. You get what's called a supersaturated solution, beyond the normal saturation point, by simply heating it. Let's just say this glass of water would normally hold 3 tablespoons of sugar at room temperature. Well, if I boil it, I can get 6 tablespoons of sugar to dissolve. If I just keep it getting keep it real hot, I might get 7 or 8 tablespoons to dissolve in there. Then you can take a pencil, lay it across the top with a string hanging down, or several strings down into the solution, and let it cool down very slowly. As it cools, the extra sugar is going to have to crystallize. Because at room temperature, it's only going to hold 3 spoonfuls, and I've got 7 in there. So where's it going to go? Well, it'll crystallize to anything that it can touch. So it'll start to form crystals on the string. Rock. Yeah, add some food coloring. Rock candy. You can buy it stores all over, you know, rock candy. That's what it is. Now, if I let it cool down very slowly, let's say I let the temperature drop 1 degree per minute, I'll get big crystals. If it drops 5 degrees per minute, I'll get small crystals. So by looking at the size of the crystals that are formed, you can tell how fast it froze. And the ice crystals in the blood of the mammoths are real tiny, which is a very, I think, pretty airtight proof that they froze very rapidly. The other thing that tells us they froze quickly is the food in their stomach would continue to rot after the animal died. I mean, hydrochloric acid works whether his stomach acid doesn't know he's dead, right? Nor does it care. It's going to keep doing its job. It's going to dissolve the food. And yet the food is not dissolved. So if you have these problems with the small ice crystals and undigested food, then you have to conclude they froze extremely rapidly. I talked to a guy who shot a deer, or hit a deer one time with his car. No, hit a moose. Where was that? In Maine. Okay. He went back the next day because he thought he might have killed it. He hit it at night. He hit it pretty hard, but he was able to drive on. And he went back the next day, and sure enough, he had killed the moose. And the outside 6 inches of the moose had frozen because it was like 20 below zero. But when he cut into it, the inside had begun to rot. Well, the body heat's trapped. The ice on the outside makes an insulator. It freezes from the outside in. So it traps the heat. Just in 24 hours, it spoiled the meat because of all the heat. So when they kill these moose, they cut them open and cut it in pieces so it freezes from all sides. Okay? Well, in order to freeze an elephant all the way to the center in less than 5 hours, you have to get it in something really, really cold, like 300 below zero. Walt Brown says 150 below zero. He may be right, I don't know. But the people I called, Bird's Eye Frozen Food people and others, said you would need about 300 below zero in order to freeze an elephant in 5 hours. Remember the liquid nitrogen we had here, you know, how fast it freezes a hot dog or a banana or stuff like that? That's about 312 below zero, I believe, is the temperature for nitrogen, liquid. Well, the coldest temperature ever recorded at the South Pole was 127 below zero. I just saw something on the news the other night. They broke the record, 129 below zero or something like that, you know. Big deal, and who cares, right? That cold, it doesn't matter. The movie, or the book by Jack London, To Build a Fire, you know, where he's out there freezing to death, you know, and he said you can tell how cold it is if you spit and it freezes as soon as it hits, it freezes. It's about, 50 below. And he was spitting and it was freezing in the air before it hit the ground. So it has to be 75 below, somewhere around there. But if you spit and it freezes when it hits the ground, it's time to move south. That's my thinking on the situation. All right. Anyway, the frozen mammoths, if it takes 150 to 300 below zero, we have to explain, since it never gets that cold on Earth, something had to happen. So I'm going to lay out all the different facts that I think need to be explained, and then give you my theory, which I think will explain why I've selected this theory to explain, try to explain all of these things. I call it the Hovind theory, so nobody else gets blamed for it, in case I'm wrong, right? And I probably am wrong on some things. But I was strongly influenced as a young Christian by a video that I saw. Actually, it was just a film strip with a tape recording that goes with it by Don Patton, The Biblical Flood and the Ice Epic. That's where I got the beginning of this idea. I said, wow, that makes sense. And I've read lots of books by Henry Morris and all these guys, and I really admire their work. And I've tried to put together what I think is a coherent theory, and I really like Walt Brown's, even though he disagrees with me on a couple things. I think his hydroplate theory is very logical, reasonable, well laid out. He doesn't explain a couple things, like the giant insects, which I think, you have to have a canopy. I don't see another way to get giant insects. A lot of people have influenced this. John Morris, Henry Morris, Steve Austin, Don Patton, Walt Brown, Carl Baugh. And it's a shame, but many creationists haven't learned to eat the meat and spit out the bones. You can glean something from everybody. Okay, I learned things from Hugh Ross. He's got some amazing articles. Now, I disagree with him on just about everything, but there's some things I agree. I've learned things from Jehovah's Witnesses. You can eat the meat and spit out the bones. I mean, it's not that complicated. You can learn something from everybody. So, some people, if they don't like one thing about one person, they blackball them from then on. You're no good. Nothing good can come out of you. Like they said about Jesus, can anything good come out of Nazareth? My theory is slightly different from any other that I've seen, that combines aspects of many other people's theories. I must bear the responsibility if it's wrong. I'm going to review some things about science, or maybe it'll just be teaching the first time if you never knew it. And then we're going to try to explain some things, like fish fossils found in diatomaceous earth by the trillions. I've got a block which we'll show you later when we get to that. It has probably 30 fish fossils in 1 square foot. What happened? This is a piece of shale. When they drill down into this shale, oftentimes they find oil-bearing shale. You can actually see in the sides of this, oil was dripping out in a few places, right here. And you can see a clear impression of a fish that has been pressed and turned into oil.
Wow.
Pass that around. Be careful. We'll try not to touch the fish part so it doesn't wipe the oil off. There's the fish. He turned into oil by the pressure. What happened to this world? Why do we find petrified clams and snails and seashells on top of Mount Everest? Something strange happened on this world. Okay? The inverse square law is the first thing I want to explain to you. If two bodies are attracted to each other, like say the Earth and the Moon, they're pulling on each other with their gravity. The more massive a planet is, the stronger its gravity is. You can actually get two huge steel balls and park them next to each other, and they each have their own gravity, and they'll pull toward each other. And you can hook up bars on there and hook a spring to it and tell how hard it's pulling, and you can check the force of gravity between two giant steel balls or two big lead balls. They have not a magnetic attraction.
Has to do with size.
Gravity has to do with mass, not size. You can have this room full of marshmallows is not as massive as this room full of lead. Okay? Your mass does not change. If you go out in space, you still have the same mass. Your weight changes. You can be totally weightless, but if somebody came up and pushed you, it would be exactly the same as pushing on Earth in a frictionless environment. A 200-pound tackle hitting a 150-pound end, the 200-pound tackle has more mass, and so he will win in the collision. A semi hitting a Volkswagen in space will do the same as it does on Earth. Smash the Volkswagen. Right. So the mass doesn't change, but the weight does. Okay? Inverse square law says if the distance between two attracting bodies is cut in half. Let's look at the Moon is about 250,000 miles away. If we brought the Moon back into 1/2 that distance, 1/8 of a million miles, gravity is 4 times stronger. The pull between those two planets is 4 times stronger. My dad was an electrical engineer at Caterpillar Tractor Company. He had to design the lighting for factories. And the inverse square law applies with lights. If I measured how much light is on my hand from, how many 100 miles away, candle power, which is how they measure, it's equivalent to 500 candles. If I move that light in to half the distance,
You have 2,000.
I'd have 2,000 candle power. Inverse square law says if the force of attraction between two objects is inversely proportional to the square of the distance between them. So if I brought the moon back to 1/3 the distance, you'd inverse it, flip it over, and square it. 9 times the gravitational pull. Inverse square law applies when you're dealing with gravity, with light, with magnetism, same thing. How strong is the magnet? It's inversely proportional to the square of the distance between the two magnets, and it works with girls. When the distance is halved, the force of attraction is quadrupled. Now, many fellows have not caught on to this until it is too late. See, I travel a lot. I've been home 7 Sundays, I think, now in 9 years. So when you come home after a trip and you get 10 feet away from your wife, it's like, hello, dear, how are you? When you half the distance, it's 4 times the attraction. When you half it again, it's too late. The force of attraction overpowers all resistance at this proximity. So the secret is stay about 10 feet away and solve most of your problems. Next thing you need to remember, or refresh your mind, or teach you new, is a spinning top behaves in a very particular manner. If a spinning top is hit by something, it will wobble, or a gyroscope will do the same thing. It'll wobble, and it follows a surprisingly predictable pattern. Let's say we got a gyroscope spinning on the table, and we thump it with something, throw a rock at it. And it wobbles over 20 degrees and comes back up. Then wobbles over 15 degrees and comes back up. And wobbles over 10 degrees. As it wobbles, it'll follow a pattern. Now, it may be wobbling, tipping this way or this way or this way. But like the Earth, today is tipped over 23.5 degrees.
And pretty stable.
And the pole is wobbling just a very tiny little bit. Not much. The pole, the line between the North and South Pole, is always pointing toward the North Star. Let's say the North Star is up in that tree someplace, and the sun is right here. As we go around the sun, it always stays pointed to the North Star. That doesn't change. But our tilt in relation to the sun would change depending which side we're on. So if we're over here on this side, we have winter because we're tilted away from the sun. If we're over on this side, we have summer because we're tilted toward the sun. We get longer days. And if we're like we were yesterday, the first day of spring, March 21st, the sun is directly perpendicular over the equator, which means everybody gets 12 hours of daylight. North Pole gets 12 hours of daylight, South Pole gets 12 hours of daylight, equator gets 12 hours, and 12 hours of darkness. Now that only happens for a few seconds, and then we move on, and it starts to get, longer days down here and shorter days up here, or whatever. Actually, it's the other way around in the spring. We'd be on this side now, because as we travel around. So our days are going to be getting longer. So yesterday should have been 12 hours of daylight, 12 hours of darkness. Today is probably 12 hours and 2 minutes of daylight. Slowly gets longer. Now, it gets longer faster closer to the poles. At the peak of summer, on June 21st, the longest day of the year, they're going to have 24-hour daylight. We're not. This circle of 24 hours of daylight slowly grows out to the tropics and then goes back in. This circle, the size of that circle of pure light or pure darkness, either one, same thing happens at the pole, at both poles, opposites. Who cares? Okay. If a spinning top is struck by something, it'll wobble around and follow a predictable path. You can actually graph out, if you made a graph over time, okay, after 2 seconds it was leaning 5 degrees, after 4 seconds it was leaning 8 degrees. If you graph time over angle, you would end up with a wavy line, and you can actually go back and look and determine when it was struck by the wavy line. Okay? George Dodwell, famous astronomer, gathered data from all over the world. There's a lot of evidence that the Earth has wobbled down through its history. From the article here on the website, MSNBC, by Randolph Schmid, Associated Press, he said, scientists studying underwater volcanoes have found evidence the Earth may have wobbled like an out-of-balance ball 84 million years ago. relocating the poles and shifting the location of Washington to the tropics. There are numerous different bits of evidence that tell us the earth has wobbled. For instance, Stonehenge, the rocks piled up there in England, and the temple Amun-Ra, Napoleon's savants drew this picture in 1798. I think it's been quite a bit more destroyed since then. Indicate that they built this thing so that the pillars would line up on June 21st with the sun. See, if you're really smart and you know exactly where the sun's going to be on June 21st, and you know that's the longest day of the year, or if you know exactly the angle the sun's going to be on the shortest day of the year, which is December 21st, it used to be December 25th. But because the earth is moving a little, it's now December 21st. December 25th was the shortest day of the year. And a lot of the really smart heathen would build this big temple so that the light shined right through this circle and right through this circle and struck this gold plate, you know, on that day. And they would tell their people, now, I'm God, and if you don't bring me presents, I'm going to make the sun keep going down, down, down until it disappears. But if you bring me all your gold, I'll make the sun come back. They would have all these elaborate ceremonies to have the rebirth of the sun god, and that would happen on December 25th, which is a pure pagan holiday. And here all the Christians today celebrate Christmas. I don't think most Christians know that, and I'm not against celebrating Christmas, but I think you do need to understand it has 100% pagan roots. It's December 25th is a pagan holiday. The Inca Indians and the Aztecs would have all these sacrifices, you know, where they would cut people's hearts out and offer them to the gods. Oh, please bring the sun god back. You travel all over Mexico, you see these suns every place. The plates are made like suns. The clocks have like suns, you know. If you look at a lot of the Catholic statues, you'll see Mary holding baby Jesus, and there's a sun coming up, the rebirth of the sun god. Average Catholic doesn't have a clue what they're in, but when they find out most of their symbols are satanic and pagan, they say, wow, I didn't know that, you know. And the honest, intelligent ones will say, wow, I better investigate this. Others will just get mad at me for even saying so, you know. But even when they see them holding the wafer, you know, that they think turns to the body of Christ, it'll have the little rays coming off representing the sun. It's the worship of the sun god, the pagan religion. Okay? That's another whole long rabbit trail I don't want to chase too far. So, these temples, though, today do not line up with the sun. But you can tell where the sun should have been to make the temple line up. The temple didn't move. And so they can calculate what the tilt of the earth would have been. Based on that temple, and when it, you know, they say, well, the earth is tilted over 23.5 degrees. It must have been tilted only 5 degrees when this temple was built. So George Dodwell spent years and years and years. He's a famous Australian astronomer. He gathered data of how much was the earth tilted when that temple was built. And by putting together all this data on a chart, he said it looked to him like something struck the earth 4,350 years ago, which is what time our Bible says we had a flood. Okay, we'll take a little break. We'll get into more of that when we get back. Today, the earth is tilted over 23.5 degrees from the line perpendicular to the sun. So as it travels around, we're always tilted 23.5 degrees, and that's what causes our seasons. And that's what causes what is called the solstice shadow. In the summer, the sun is higher in the sky than it is in the winter. Now, at the equator, it'd be just the opposite. In our summer, you know, they're having their winter. And Dodwell said, the recorded tilt of the earth, based on the temples that he studied and the evidence of what the earth was tilted at the time the record was made, says that it made a wavy line of a graph that was the match of a wavy line a spinning top makes when struck by an object. It appeared to him that something struck the earth 4,350 years ago. So just by looking at the graph that he made of how much was the earth tilted and when was the observation recorded, something struck the earth 4,350 years ago, according to Dodwell. Well, that's about the time of the flood. Okay, so we're going to put 2 and 2 and 2 and 2 and 2 and 2 and 2 together here, and end up with 16 or 20, whatever it comes out to be. But I'm going to give you all the evidence first to support, and then so my theory will hopefully make sense. This tilt of the earth is what causes our seasons. The first mention of cold weather. Now, seasons are mentioned in Genesis chapter 1, I think. But it's not necessarily referring to seasons as in summer, winter, spring, fall, though it may be. The Bible simply doesn't say. I think it's referring more to the length of the year, a yearly cycle. 1 year is one trip around the sun. The first mention of cold weather, however, is right here in Genesis chapter 8. Now, this is after the flood. While the earth remaineth, seed time and harvest, and cold and heat, and summer and winter shall not cease. Many people think, and I guess I would have to be in that category, that probably there weren't any cold winters before the flood came. If the earth were not tilted 23.5 degrees, you would still get warmer at the equator and still a little colder at the poles, but much less of a temperature extreme than we have today. It'd be just about like springtime all the time. Always 12 hours of daylight, 12 hours of darkness, which would be very interesting because you could tell what time it was without a watch. Where's the sun? It's always in the exact same place. Of course, maybe you didn't care what time it was. Okay, but they could have told. Also, the magnetic field may have been stronger back then, so you could actually tell which way is north all the time. We'll get into that in just a minute. That's an interesting concept. Carl Baugh's got a good book called The Panorama of Creation, where he goes into what he thinks it was like before the flood and some of the neat features they would have, like you couldn't get sunburned with a canopy overhead. You always had the extra air pressure, always full of energy, stuff like that. The first mention of cold weather, though, is after the flood. I think some animals, like polar bears, for instance, seem to be more designed for colder weather. They're very uncomfortable in hot weather. If it's always, say, 70 degrees, then it probably wouldn't matter much. They might want more like 50 degrees at the pole and 80 at the equator, some temperature difference, but nothing like the extremes we have today. Next thing to keep in mind. The moon has craters all over it, but they're not evenly distributed. It's been a puzzle to scientists for years. I mean, if the moon is just getting hit randomly, statistics tell us the craters would be evenly distributed. If you just blast the moon every once in a while, the craters should be all spread out evenly, but they're not. It's almost like the moon was hit in a catastrophe in a relatively short time, maybe a couple of days. Most of the craters were formed. The moon is about 1/4 the size of the earth, so it would be about like a softball compared to this globe. 250,000 miles away. I think that works out to be 30 Earth diameters. So if this is 1 foot globe, 30 feet away would be the moon, the size of a softball. The moon takes about 29 days to go around the earth. It also takes 29 days to turn, turning real slow. So the net effect is we never see the other side. As it goes around, it's turning at exactly the same speed so that the same side is always facing toward the earth.
Now, over hundreds of years, would that change?
I don't think they've noticed it changing at all. I may be wrong on that, but I think it was the Soviets were the first ones to go to the backside of the moon and get pictures. Might have been the Americans, I don't remember. There was a big race. Who can be the first one to get a picture of the back of the moon? Oh, wow. Spend billions of dollars to get a picture. And guess what? It looks pretty much like the front. A bunch of craters, all right? But there are not as many of the huge craters. The ones on the front are called mares, which is the Latin for sea, because it looked like an ocean up there. The Sea of Tranquility, Mare Tranquillus, was one of the seas that they landed in. The craters, though, are not evenly distributed. They're not evenly distributed on Mercury either. Mercury is much closer to the sun than we are. Earth is 93 million miles from the sun, which is called 1 astronomical unit. And Mercury is, I think, 0.39, if I recall, about 1/3 of an astronomical unit. So it's 1/3 of the way, or twice as close, however you want to say it, to the sun as we are. Mercury gets extremely hot, being that close to the sun, and it's full of craters. But they also are not evenly distributed. Mercury gets hot enough that you would get what's called crater creep. You also get that on the moon. If we blasted went out with a 357 and shot a hole in the mud out here in the yard, it would make little walls on the side. Over a period of time, it would slowly, even if it didn't rain, it would slowly creep back down toward level, like putting a pile of tar in your driveway. It'll slowly settle out. The sides of the craters on the moon are still real steep. There's been very little time for crater creep, for them to slowly sink out. Now the moon has a lot less gravity, so crater creep is not near as strong as it would be on the Earth. But on Mercury, with the hotter temperatures, crater creep is more of a problem. The craters should have melted out smooth again. And they're not. The Grand Canyon on Mars is actually much larger than the one on Earth. I forget the size, but it's absolutely monstrous. I forget the name of it too. I used to know. Who cares anyway? But this canyon on Mars is, scientists have studied this, and in 1998, Scientific American ran a big article about the crater on Mars is proof there used to be water, and they say this formed in a few weeks.
Why don't they say that about the
Yeah, why can't you go look at, here you're looking at a planet where there's very little, if any, water, and you can obviously see this canyon formed in a few weeks. You can go to Grand Canyon on Earth where we got tons of water and can't figure out the same thing. Hello, is anybody home in there? It had to form quickly. These canyons are giant, and there's just very little, if any, water on Mars. Some frozen at the poles, I think, but hardly any. Now, Mars is a much smaller planet than Earth, and it's farther away. It's 1.5 astronomical units, so 50% farther than Earth. A quick way to memorize the distance to the planets is to do it with astronomical units. If you memorize the sentence, my very extravagant mother just sent us 90 parakeets, that's the way to know the planets in order. My very extravagant mother just sent us 90 parakeets, or 90 pizzas, or something, okay? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Mercury, I think, is 0.39, if I recall. Venus is about a 0.7 astronomical units. Earth would be 1. Mars is 1.5. Jupiter is 5, if I recall. Saturn is like 9, and it goes on out to 39. I haven't studied this in 12 years, but I just remember these just off the top of my head. So you can get the astronomical units and multiply that number times 93 million miles. That'll tell you the distance in miles. But it's easier to memorize as astronomical units. Okay, Mars is farther out, so it doesn't get as hot, doesn't get as much sunlight as we do here. Plus, it's a smaller planet. I think it's roughly half the diameter of the Earth. Earth is about 4,000 miles, so at this scale, Mars would be a little smaller than a volleyball compared to the Earth. 8,000 miles across. Mars is 4,000, right. Okay, half the diameter, which is not half the size of the Earth. It's much less than half the size, volume. When you're discussing the size of planets or balls, you've got to decide, are you talking volume or circumference or surface area or, diameter? There's several ways you can make.
Surface area be half?
The surface area of a sphere is, it's been years, 4/3 pi r cubed, I believe. Take the radius cubed times pi times 4/3, I believe is the formula for surface area. So the surface area will be proportional. It's always proportional to the radius. As the ball gets bigger, you get more volume compared to the surface area, which is a problem we'll get into later with why bugs can't get to be huge. Okay. Anyway, next thing to keep in mind for this theory. There's an effect called the Meissner effect, probably named after somebody named Meissner, is my guess. The Meissner effect is when you see a magnet floating on top of another magnet. You put two north poles together, they push away, and if you do it right, you can actually get them to float. There was a game we had when I was a kid. We had a bunch of little magnets with holes drilled through them and a little stick on a block of wood, and you put the magnets on there, and you try to put them north against north and south against south, and they slowly lift each other up. And there's spaces in between. They're all floating on this stick. Now the ones at the bottom are pushed tighter because just more weight. Okay. The Meissner effect is a magnet floating above another magnet. Meissner is a guy apparently who studied it. Japan's trains, the super train that I rode over there when I was there, that travels like 170 miles an hour or something like that. It was incredible, And we're going down this track, and another train came by. Must have been that far away. And here I'm sitting by the window, and said, "Woo!" It scared me half to death. You know, closing speed would have been about 250 or something. You know, don't stick your head out the window. You won't see it again. They use superconducting coils, and it actually, the train levitates. It lifts up off the tracks because of the strong magnetic field, which means no friction. Till you turn corners. They have special wheels to turn the corners, and even those are magnetically. They try to keep it away from the rail. The less it touches, the less friction you have, less to wear out. Now, it takes a very strong electric current to maintain that strong magnetic field, so they still use a lot of power, you know, to do this. But called maglev, magnetic levitation, maglev trains, all right?
So they are using that.
Oh, yeah. It's still not, I don't know about perfected if this is the right word, but it's not real common. I know there's talk of putting one in between Washington, D.C. and New York or Boston, like that, you know, a maglev train. Extremely expensive to do. But it certainly is possible, okay, to do. Anyway, magnets float on top of other magnets. That's called the Meissner effect. Keep that thought in mind. Number 5. Comets are flying around through space, like Halley's Comet, Levi Comet, Shoemaker Comet that hit Jupiter a couple years ago. A lot of comets are flying around. Some come by pretty regularly. Some every few years. Some, like Halley's Comet, every 76 years. You see it once, it's going to be 76 years till you see it again. Very few people will live long enough to see it twice because they're probably not old enough to know what's going on the first time it comes by. Nobody lives long enough to see it 3 times. But comets are very commonly out in space are simply giant snowballs. They're ice. Some of them are stone. Some are nickel, which is a pretty rare element on Earth. A lot of the comets, though, are very high in nickel content, which is what they use to make nickels. It's also what they use to mix it with steel, mix it with iron. You can melt your iron, mix in some nickel, and it makes the iron more resilient, like they use it for gun barrels. You melt nickel in with the iron, and when the bullet explodes, the metal swells up and goes right back. Otherwise, it would swell up. Next time you fire, it swells up a little more. Pretty soon the bullet's flopping around in there. And it doesn't hold your casing tight. So over the years, they've discovered which alloys do which things. You know, chrome will harden it, and carbon will harden it, and nickel. At Laterno, in Longview, Texas, was Laterno, where they make the huge tractors and stuff, you know. One of the guys that worked with me, or that went to our church, was a good friend of mine. He worked there all day long, shoveling in different amounts of different materials into the furnace for different alloys that they wanted. It costs a lot of money to make it, you know, you don't want to, you could make all your parts out of, you know, pure gold, and the tractor costs a lot of money. Plus it'd be pretty soft, it wouldn't work very good. So like for certain gears, they'll say, okay, we want X number % nickel and X number % cobalt, and, you know, and he would have to, they would just guess it by shovelfuls, you know. It's 4 shovelfuls is like you do when you mix your mortar for cement, you know, for your bricks. And he brought me samples of molybdenum, manganese, cobalt, and also, I don't remember cobalt, but all sorts of different metals, and had them on my shelf in my class when I taught science there, you know. Had a little sign on it, this is a piece of nickel, you know, little bars of nickel. Probably not worth a lot of money, but it was just interesting to have, you know, pure nickel and pure different metals. Many of the comets flying around through space, though, are ice, just big snowballs. Now, because outer space, away from the Earth's atmosphere, which keeps us nice and warm like a blanket, the Earth's atmosphere keeps us warm, but when you get outside that, it gets real chilly.
Even in the sun?
Oh, yeah. Because outer space is basically 400 below zero. Fahrenheit. When you get to 459.6, you're at absolute zero. As far as we know, negative 459.6 degrees Fahrenheit is called absolute zero. On the Kelvin scale, on Celsius scale, it's negative 273 Celsius, which is the same temperature, or 0 degrees Kelvin. There's another scale too, by the way. Nobody hardly uses it. I forget what it is now, but it doesn't matter. Outer space is somewhere around negative 456 degrees Fahrenheit, is what they guess. There's about 3 degrees off of absolute zero. And so some have argued, oh, this is proof for the Big Bang, this 3-degree background radiation. Because in some places when they look in space, it's a different temperature than other places. Well, ask them how much different. It's 30 millionths of a degree. First place, I'm not sure you can measure 30 millionths of a degree from that far away. Okay, but let's assume they can. What does that prove? That certainly doesn't prove the Big Bang theory, okay? But they call that the echo from the Big Bang. They're just really desperate to support that theory. Anyway, you got a chunk of ice floating around out there through space for hundreds of years or thousands of years. It's also about the same temperature. Real chilly. If it had any heat, it would be dissipating. So these ice balls are flying around, ice comets. Next thing to keep in mind, if you throw a snowball too fast, it'll break apart. You couldn't shoot a snowball out of a cannon. It gets up to a certain speed, it comes apart. There's a long, complicated reason for this. It has to do with how tightly together are the molecules of water or ice stuck to each other, called the tenacity of the ice. How tightly do they hold on? At a certain speed, they're going to come apart. Next thing to keep in mind. The Earth has a magnetic field, but the magnetic field is getting weaker. Since it's been measured, the Earth's magnetic field has lost 6%. In 150 years, it has lost 6% of its strength, since a guy named Gauss measured it. Okay? That'd be a good quiz question. The magnetic field is getting weaker. It's lost 6% in 150 years. The magnetic field is what causes the northern lights. If you can imagine, you ever seen you put a magnet in a piece of paper and then sprinkle iron filings on it. You know, it makes the little lines, okay, like an apple core. Earth's magnetic field dips in at the poles, and all around the place where it dips in are the northern lights. You get the northern lights or southern lights if you're at the South Pole if the sun is having storms. Storms on the sun will send these things down, and that apparently is what causes the magnetic field. If the northern lights are going crazy, you probably are going to get lousy radio reception. You get a lot of static on your radio. When I was a young teenager, before I was even saved, my dad got me interested in ham radio, and I built my own transmitter. You know, Heathkit, put it all together, you know, and transmit and talk all over the world with Morse code. If the sun's over here, the sun's solar wind is pressing the magnetic field in closer to the Earth. On the opposite side, you can see the picture here, the sun's rays are drawing the magnetic field away from the Earth. It kind of pulls it out like a teardrop. So at night, you get better reception. If you have an AM radio, go through the radio during the daytime and count how many channels you can pick up. If you slowly turn the dial, and so let's say you can pick up 25 channels in the daytime. Do the very same experiment at midnight, you probably pick up 300 channels. Because the magnetic field's being drawn away, and there's low interference, and it's unreal how many stations you can pick up. So at night, I could hear stations from Mexico up in Illinois. You could hear them from, you know, a long ways away on a little transistor radio. Little pocket radio, stick your little antenna up and listen to, you know, South America. It's really incredible. Who cares? Okay. The Earth's magnetic field, though, dips in at the poles, and that's what causes the northern lights. Next thing to keep in mind. The pre-flood world was a lot different than it is today. I believe the Bible indicates that there was a canopy of water overhead. I don't know of any other way to explain all the phenomena we see.
What does Walt Brown think about that verse in the Bible? They separated the waters which were under the firmament from the water.
I don't remember his answer on that. We sat at Phoenix Airport for probably 2 hours, had lunch and sat there and talked for a couple hours. Really nice man, very smart man. PhD in physics, retired lieutenant colonel, I believe, from the Air Force, and now spends all of his time working on that one book.
Really?
And it shows. He's on his 27th edition. The book In the Beginning. It gets better every time. You know, I had his 4th edition. I was going through my bookshelf cleaning out, and I found one that I'd gotten years and years ago, and it was pretty bad. I'll go back and look at my original seminar notebook and think, oh, this is embarrassing. We've come a long way with that thing. We're on our 15th edition there, and hopefully that'll keep getting better. Anyway, magnetic field of the Earth is getting weaker. The Earth used to have a canopy of water above. Next thing to keep in mind, who was Peleg? I hate to say this about the Bible, but Genesis chapter 10 is a boring chapter. You're reading through the Bible, you come to chapter 10, you know, all these guys begetting everybody else, and nobody can pronounce these names except Alexander Scorby, okay? He pronounces every one of them just right, okay? It's incredible. So when I go through this, I listen to it on tape, you know, and let him pronounce them all for me, you know. My preacher always said, when you come to one of these names, just say grasshopper and go on, you know, because who knows, who cares what their name was. But the names all have meanings in the Hebrew. It's just really quite a study if you want to get into all that. But you're reading through Genesis chapter 10. It's got all these names, you know. So-and-so begat so-and-so, and he begat so-and-so, and he begat his son, and he begat somebody else. And you come to verse 25. And it says, unto Eber were born 2 sons. In the first place, this is unusual. Most of them, probably all of them had lots of kids. Why does it mention 2 sons for this guy? The name of the one was Peleg. For, that means because, in his days was the earth divided. Interesting. This is one of the few people in this whole chapter that it says anything about, you know. The rest of them, it just gives their name. But Peleg, it says, in his days was the earth divided. And it also names his brother. I don't recall. I think maybe there's one other one in the chapter where it even names his brother. If there are any brothers, okay? It says his brother's name was Joktan. Now, Joktan is the Hebrew word that means shorten, to make shorter, to diminish. And Peleg is the Hebrew word that means divide. So here we have a verse that tells us in the days of Peleg, we have division and shortening. Something is made shorter and something is divided. Doesn't tell us what. Usually they would name their son after some great event or after, you know, there's a reason for the names in the Bible, okay? Like the Indians, we talked the story about. The Peleg means divided, and Joktan means shortened. Well, if you look at the graph in the back of your seminar notebook, the timeline of the different people's lifespans, you see Peleg right there. By adding up the dates, Peleg was born 100 years after the flood. He lived to be 239 years old, and he died. Well, his dad and his grandpa and his great-grandpa lived up into the 400s. His great-great-great-grandpa, Noah, lived to be 900. 950. Noah's son Shem lived to be 600. So you go from 950 to 600, 3 of them for 400 years old, and all of a sudden, 239, 238, 239. Then Peleg's son Reu lived to be 239, and then 230. Then it drops off to 148, and then 205, and that's the last guy over 200, Terah. Abraham, 175. Isaac, everybody's lifespan gets shorter and shorter. King David finally died at 110. He was considered real old. Moses was 120 and considered real old. Today, if somebody's 120, they're real old. So what happened in the days of Peleg? Well, we'll cover that when we get to the Hovind theory. And number 9, the pre-flood world, according to the Bible, had a layer of water under the crust of the earth. Now this is critical to keep in mind. The Bible tells us in Psalm 24, the earth is the Lord's, and the fullness thereof, the world and they that dwell therein. For he hath founded it upon the seas, and established it upon the floods. What does that mean? God built the earth on top of the water. Now some people back 500 years ago were teaching, you know, the earth is flat and there's a layer, it's sitting on a layer of water, which is sitting on the back of a camel or the back of a turtle or something, you know. Nobody ever said, well, what is that standing on, you know. Well, we don't know, we can't go that far in our theology. But, okay. Actually, I think there was a crust of the earth, maybe 10 or 15 miles of solid rock, and then water underneath, called subterranean aquifers. Mentions it again in Psalm 136. To him that stretched out the earth above the waters. So when God first made the earth, there was a layer of water under the crust of the earth, according to Psalm 136 and Psalm 24. Something was different. We still today have water down in the ground, sometimes huge chambers. You can go down in some of the caves, like Carlsbad Caverns, and go down there, and then they get into giant underground lakes. You can actually go scuba diving. Dangerous thing, pure black, in a cave. It's easy enough to get lost in a cave. Imagine scuba diving in a cave. You got 45 minutes of oxygen, you run out of, just tough. So usually they're very careful about spelunking and scuba diving at the same time. Okay, last thing to keep in mind. Sometimes there are two ways to look at things. How fast was that calf going? Remember that from seminar part 4. I made a decision years ago, I'm going to believe the Bible until somebody can prove it's wrong. Other people have decided they are not going to believe the Bible until you can prove it right. I don't think that's a wise choice, but that's up to them, okay? It's like the atheist that came to the preacher and said, "Preacher, I don't believe anything in the Bible." He said, "If you can prove one verse scientifically, I'll believe it." The preacher said, "Okay." He grabbed the atheist around the head, grabbed his nose, and began twisting his nose back and forth. Of course, pretty soon the blood is pouring down his face. He said, "Man, what are you doing?" The preacher said, "Well, I was proving the Bible. It says the wringing of the nose bringeth forth blood." Proverbs chapter 30. I don't recommend you do that, but it is in there. All right? He proved a verse in the Bible scientifically. So next week when we come back, we're going to give you the Hovind theory of what I think happened to cause the flood, to freeze the mammoths, to cause the ice age, etc., etc. And I think you'll find this at least a plausible theory. Other people think, "Oh, no, it's crazy. It can't happen that way." Well, show me where I'm wrong, please. Okay? Build a better mousetrap and show me how you catch them. I'd like to see that. Thank you. See you next week. All right, this is class number 2 of our CSE 104, and hopefully if we can hurry, we'll try to get everything done in the next 9 weeks and the next 9 classes and finish up what's on our seminar part 6 and our seminar part 7. Okay, we told you last week we reviewed some science, okay, about the Meissner effect and about the super cold temperatures in outer space and throwing a snowball too fast, etc., etc. I'm going to give you the Hovind theory of what I think happened. This is not all original with me, nothing's original with me. But I've put together bits and pieces that I've gleaned from various places that I think make sense about what might have caused the freezing of the mammoths, the tilt of the earth, the beginning of the seasons, the cracking of the crust of the earth, all these things that apparently happened at the time of the flood. Here we go. First I'm going to tell you what I'm going to tell you, and then I'm going to tell you, and then I'm going to tell you what I told you. That's supposed to be a good teaching technique, okay? So I'm going to go through real fast first, 8 points I want to cover, and then we'll go through and talk about each point. Number 1, I think Noah and the animals got safely into the ark. God shut the door. Number 2, a 300-degree below zero ice meteor, in space is full of ice comets, came flying through the solar system and began to break apart. As it broke apart, some of the fragments got caught and became the rings around other planets. Saturn, Uranus, and Neptune have rings around them, ice rings. We'll get into that in a minute. And some of the fragments hit the planets and caused craters like the moon, and some of the fragments hit the earth and landed on the North and South Pole, freezing the mammoths. Point 3, as it approached the earth, it shattered in space. Super cold snow and ice rained down around the poles, mostly around the North and South Pole. Then this sudden dump of ice caused the earth's crust to crack, which released the fountains of the deep. The rapid spreading of the ice caused all the ice age effects, carved out the Great Lakes, made all the drumlins and terminal moraines, and we'll talk about that in a minute. It buried the mammoths in super cold snow, 300 to 400 below zero, so they suffocated, standing up, and froze in 3 to 5 hours. It was so cold. It caused the earth to wobble for the next few thousand years, and it made the canopy that used to protect the earth collapse, because cold air hits warm air, rains, all the rain came down, the canopy's no longer up there. We're not protected like they were before the flood, and the earth was completely covered by water. Then, during the first few months of the flood, the dead animals settled out and were buried. Those became fossils. Swirling waters deposited great piles of dead plants and animals, and they became coal and fossil graveyards over the next few hundred years. During the last few months of the flood, the unstable plates of the fractured earth shifted, moved around. Pieces lifted up, other places sank down. Thin spots would sink down, and the water would rush in, filling it in to make an ocean. The places where it lifted up would become the mountain ranges. On the way from the top to the bottom, it's going to wipe out a lot of canyons, or wash out a lot of canyons in a hurry. So canyons were eroded because the sediment was still fairly soft after the first few hundred years after the flood. Over the next few hundred years, the ice caps generally retreated from Kansas City clear back to where they are now in Alaska. This would add water to the ocean, making the oceans colder, deeper, and wider, which is why we have a continental shelf, which we'll get into in a minute. Cold water absorbed carbon dioxide, and lifespans were shortened in the days of Peleg because of the lack of greenhouse gases, which allowed more radiation in, and numerous factors probably entered in here, but the days were lifespans were shortened in the days of Peleg. Lastly, the earth still shows the effects of this devastating flood as a reminder of God's hatred for sin. Okay, start at the beginning now. I told you what I was going to tell you. Now I'm going to tell you. Noah and his family got into the ark. The Lord said unto Noah, Come thou. Now there's an awesome sermon right here. God didn't say, Go into the ark. He said, Come into the ark. So where does God have to be in order to say that? In the ark. Now that'll preach, okay? There's a sermon in there somewhere. Somebody ought to find that one, okay? I don't mind going on a year-long cruise with a bunch of animals if the Lord's in there with me. The Lord said, Come thou and all thy house into the ark, for thee have I seen righteous before me in this generation. Of every clean beast shalt thou take to thee by sevens, the male and his female, and of the beasts that are not clean by two, the male and his female. Now there's always been some interesting questions about this verse, because what was clean and unclean was not really revealed until Moses, in about 1,000 years after this flood. At least that's when Moses wrote the book of Leviticus and said certain animals are clean, it has to have a split hoof and chew the cud and all that kind of stuff. Apparently it was always common knowledge what was clean and unclean, because Noah apparently knew. Maybe this is something God told to Adam, but it simply wasn't recorded in the Bible until this time, until Leviticus. We don't know. But this is a question of, how did Noah know what's clean and unclean? It just may have been common knowledge. Why did he take 7 of some? Well, there have been a lot of speculation on this. The Bible does not tell us, okay? But let me give you some of the theories of why he may have taken 7. After the flood, of course, they're going to have something for sacrifice. If you only have 2 of each kind and you sacrifice one of them, you now have a problem getting that species to keep going, right? That may be one reason. Another reason, when it says he took 7, it doesn't say if it's 7 pairs or just 7 animals. And people have argued, was it 7 pairs or just 7 animals? I don't know. I don't see where the Bible gives us enough to be clear on that either. It says, take them by sevens, the male and his female. Some people have argued that he took 1 male and 6 female, like farmers do with their cows. You have 1 bull or 1 deer, have 6 female deer and 1 male deer. That's typically what happens in nature. Okay, one has his harem or his herd, and that may be, you get a lot of genetic variety that way in a hurry. With 1 bull and 6 cows, you can get a genetic variation pretty quick, and that may be what he did. I don't know, the Bible doesn't say, so we'll have to just leave it at that. If you figure it out, let me know, please. Okay. Genesis 8:15. God said unto Noah, spake unto Noah, Go forth of the ark, thou and thy wife and thy sons' wives with thee. This is when they went out of the ark. So back in Genesis chapter 7, they went in. First God said, Come into the ark, and then he said, Go forth. The Lord was in the ark with them. Or he would have said, Come out of the ark, Noah. No, he said, Go out of the ark, Noah. That'll preach, okay? And they that went in male and female and all flesh, as God had commanded him, and the Lord shut him in. Now, he only had to bring those in whose nostrils was the breath of life, and only those on dry land. No fish, no insects were required to go. Some probably did. How would you keep them out? Hopefully no termites, but of course the ark was coated inside and out with pitch, so maybe it wouldn't have been a problem. The Lord shut him in. Now this is an interesting, God shut the door. This is a good eternal security verse. If God shuts the door, it won't leak. People say, do you think you're going to heaven no matter what you do? Oh yeah. It'd be impossible for me to go to hell, because God promised, if you have the Son, you have eternal life. He doesn't say you will get eternal life. He says you have eternal life. So if you could lose it, then you have temporary life. You don't have eternal life. I don't see how you can possibly lose something. If you have eternal life and you lost it, then it wasn't eternal. So you didn't have it. And we can go on all day on that topic. Churches split over that question right there, eternal security. But anybody reads their Bible long enough eventually comes to the conclusion that, the Baptists are right. Okay. Second thing that happened, a 300 degree below zero Fahrenheit meteor, this is in my Hovind theory, came plowing through space and cratered the moon and the planets and made some rings around some of the other planets. Some planets have ice rings around them. Mercury has a lot of craters. It looks like something made a hole, but we don't know what hit. Nobody sees the moon, for instance, get hit by anything. And yet the moon has lots of huge craters in it. What happened? If a chunk of ice hit it, it would make the crater and then melt away. See, the moon has very little gravity and no atmosphere. And it turns so slowly, it takes about 29 days to turn one time. It also happens to go around the Earth in 29 days, so we always see the same side. But because the moon is turning so slowly and there's no atmosphere to insulate it, it gets extremely hot on the daylight side, about 250 degrees. So if a chunk of ice hit, it would vaporize. Now on the dark side, it would stay frozen, but within a month, it'd be gone. So some have argued that maybe ice is what made the craters on the moon. I don't know. A chunk of ice certainly would do that and leave those features behind. Several planets, Saturn, Jupiter, Uranus, and Neptune, have ice rings around them. Why? Nobody knows where it's from or why it's this way, but they have these rings around it. Saturn's rings, of course, are famous, and you can see them with a telescope from here. We were out the other night looking at Saturn's rings, just unbelievable. But these rings are made of ice and rock, but lots of them are just plain chunks of ice floating around. Where did they come from? One theory is it came from this ice meteor. Okay, point number 3. As this ice meteor approached the Earth, or fragments of it, it shattered in space. Just like throwing a snowball too fast, it blew apart in space, and it ended up with a shotgun effect, coming down as a zillion pieces of super cold ice crystals. Some people have argued, oh, no, you can't have an ice meteor come through the Earth because the Earth has an atmosphere and it'll melt it. I understand all that, okay? If the pre-flood world had a canopy of water above the atmosphere and squeezed it down to maybe 20 miles of atmosphere, today we have 100 miles. Let's just pick a number. Say it was 20 miles thick or 10 miles thick. Adam wouldn't care. I mean, 10 miles is, you wouldn't bump your head on it, okay? It would double the air pressure. Plus, an ice meteor now, if fragments are coming through, sure, a lot of them get vaporized, not only from the temperature, but from the friction, just building up friction. But just like you can spray a hose right through the middle of a fire, you get a stream of water going right through a fire, some of it makes it right on through. Some of it gets vaporized, but some of it makes it through. You get enough going in one direction, you get a cold channel through the middle of a hot fire, and you can actually spray a hose right through a bonfire. I think you could do the same thing with a stream of ice coming in toward the poles. You would get, it would develop a cold channel where a certain percentage of it would survive the journey. And as this goes along, a bigger percentage survives the journey because your cold channel is developed through the atmosphere, a cold tube, so to speak. Okay. The Earth's magnetic field dips in at the poles, and super cold ice, I understand, can be easily statically charged and has very different properties. This is a girl with a hairdo on a Van de Graaff generator. You've seen those before. You get them all charged up and the hair stands up. There. I've been told by Carl Baugh and a few others that extremely cold ice takes on unusual properties. Water molecules are bouncing around off each other. They generally have the positive side and the negative side sort of loosely attracted. A water molecule is shaped kind of like Mickey Mouse. The big oxygen molecule and the two ears would be the two hydrogens, 105-degree angle between the two. Because they're sharing an electron, the hydrogen end is slightly positive and the oxygen end is slightly negative. So the negative attracts another positive, and water molecules they stick together. It's called cohesion, I think is the proper term for the surface tension it gets on it. But the molecules are kind of stuck together. Of course, you can break them apart easy enough. You can do it, bite it off, no problem. But they are stuck together. If you get it colder and colder and colder, it turns to ice. At about 32 degrees, depending on several other factors, but roughly 32 degrees, the water changes to a crystal, to ice. As it changes to a crystal, it takes on a very different pattern, and it actually swells up about 12%, which is why ice floats on water. And it's a good thing, or else all the fish would die. If ice shrank, almost all materials, as they get colder, they get smaller, which makes them more dense. Water is one of the very few substances that when it gets down to 4 degrees centigrade, which is about 37 degrees Fahrenheit, it's shrinking and shrinking and shrinking. When you get to about 37 degrees, it starts to swell up. It swells up 12%. Very interesting and very useful, because what would happen if the lakes froze and the ice went to the bottom. Then it would freeze again and go to the bottom and freeze again, and pretty soon the lake would freeze from the bottom up, making it real tough on the fish, right? So God designed water so that when it gets to a certain temperature, it swells 12%. Well, what happens if you keep getting it colder and colder and colder and colder, way past the freezing point? My understanding is that when you get ice down to negative 300 degrees, it starts to line up, the hydrogen molecules line up, and the oxygen molecules line up. It laminates. I've been told that at extremely cold temperatures, you can take a piece of ice at, say, 350 below zero, hit it with a hammer, and it behaves like lead. It won't break. It'll just flatten out. It becomes malleable, which is, gold, for instance, has many interesting qualities. It is malleable, which means you can hit it with a mallet, and it'll flatten out. It'll just keep spreading and spreading and spreading. You can beat gold extremely thin. And Carl Baugh has a good book called Panorama of Creation, where he says the firmament above the atmosphere was from the Hebrew word rakai, which means thin laminated sheets. I don't know if that's true or not, but it's interesting that if the firmament was indeed a layer of ice, say 6 or 10 inches thick, I don't know, enough to compress the atmosphere, and it would be suspended then by the Earth's magnetic field because it would be magnetic. It becomes metallic. People say, well, what held the canopy up there? Well, I don't know, but possibly the magnetic field of the Earth did. If in the days of Noah the magnetic field was stronger, which we know that it's losing strength now, so we assume it was stronger in the days of Noah, maybe 20 times stronger, you could suspend the Earth's magnetic field, or suspend the canopy by the Meissner effect. Okay. As this ice, though, from the meteor comes in, it would tend to be deflected largely around the poles. As this animation shows here, ice meteor would break apart. Most of it would end up dumped on the poles.
Why?
Because of the magnetic field of the Earth. That's going to tend to draw it mostly to the poles, not all of it, but some of it would hit everywhere. But a larger percentage would hit at the poles. This would end up with huge ice caps. Now, if we opened a hole in the ceiling here and started pouring in snow, it would start piling up. As the pile gets deeper and deeper and deeper, what happens to the edges? They start sliding out, right? I think that's where the ice age came in. The ice was sliding out from the stuff being piled on the poles. The Bible tells us there was water under the crust of the earth and water above the firmament. So I'm just going to believe it until you can prove it wrong. This article in Discover Magazine, 97, tells about a scientist and his theory vindicated. This guy said he saw chunks of ice hitting the atmosphere from one of the satellites. He could tell there were chunks of ice hitting the atmosphere. And they did a bunch of studies on this, and sure enough, they say, yep, it appears that giant chunks of ice as big as this house are hitting the atmosphere all the time. Now. It could be there are still fragments of ice flying around through space from some catastrophe 400 years ago, and we run into them once in a while. They don't seem to have any effect. Now the atmosphere is about 100 miles thick, so they would certainly vaporize on the way through. Just interesting thought that this guy did some studies, and it appears to be correct. So there used to be a canopy of water over the earth and water under the crust of the earth. As that came shooting out to the surface, the earth was totally covered by water during the flood, some liquid, some solid. Now some have argued, well, how do you get sedimentation under the ice caps? Good question. There are layers of sediment under the ice caps. Sedimentation indicates water, sedimentary rock. Well, ice floats on water. If you had ice dumped on the poles, it would float up, and once everything gets readjusted, it'll come back down and land. Drain the water off from under it, falls right back down. That's one theory, of what caused the ice age. Okay, this is a kind of a strange view of the North Pole. Down in the bottom right, you can see Greenland. My daughter and I flew over it a couple months ago, coming back from Ireland. We had a big storm in the Atlantic, so the pilot said, folks, we're flying way north. We are over Greenland. And for an hour, I stared out the window at Greenland. It was incredible. I bet I saw 3,000 glaciers. They're just everywhere, and it's so cool. What a bunch of wasted real estate. I mean, there's nothing you could do with it up there, unless you like ice cubes. Plenty of those. Well, on the far left, if this was a map, it'd be at about 10 o'clock. So you will see the arrow pointing to those islands. Those are called the New Siberian Islands. That's part of Russia. It's actually on the far right is Norway, Finland, Sweden, upside down to where you normally look at it. And then there going counterclockwise is all of Russia through 15 time zones. Huge country. On the New Siberian Islands, they find frozen animals. Frozen bobcat, frozen camels, frozen bison, mammoths. One man said there are so many frozen animals and bones of animals up there, you can hardly walk on the ground. Just as you walk, you're almost constantly on dead animals, dead carcasses. Well, what happened on the New Siberian Islands? All over this northern region, there are frozen things found. When they drill through the ice, like this coring machine shows here, they drill through to test the thickness. This map of the South Pole says the greatest ice thickness ever measured, 14,000 feet. Nearly almost 3 miles of solid ice. As in Greenland, the enormous overburden has depressed the continent. Antarctica, that would be isostatic rebound if it melted. It would lift up. Antarctica stores 7 million cubic miles of ice, most of the world's supply. If melted, it would raise the level of the oceans 250 feet. Let's see, how far are we above sea level right here? About 60? We'd be in trouble, wouldn't we? Most of Mississippi would be covered. I don't know what the elevation of Memphis is. I think Memphis might be 300 feet above sea level. So the water would come in almost to Memphis. That would be the Gulf of Mexico if the ice melted. Okay. Notice at the upper right-hand corner of this National Geographic map, it says the Dirty Diamond Mine, dug here, 1962, yielded anthracite coal. Coal at the South Pole. Interesting. There are no trees at the South Pole. What happened? Admiral Byrd reported, when he got near the South Pole, he reported frozen palm leaves. Well, we have a hard time getting palm trees to grow here in Pensacola. You know, you get a cold freeze and it kills them. We're 30 degrees from the equator. You would never get palm trees to grow at the North or South Pole. And there are leaves there. So, all over Antarctica, we'll get into this in a minute, they find leaves, evidence of plants, even dinosaurs, frozen and petrified at the South Pole, near the South Pole. Two things could have happened. 3 things, actually. Number one, the South Pole might have been near the equator and it moved. Pangea. You know, like they teach in the schools, the South equator used to be up here, you know, and the South Pole, Antarctica's moved around. I don't think so, but that is what some kids are taught. Or it could be there was a canopy of water over the Earth that protected it, and the whole Earth had tropical climate or near tropical climate everywhere. So palm trees grew there. Or it could be during the flood, the plants floated and landed in that location. So anyway, regardless, they do find trees and evidence of trees at the South Pole. Here's an article report. Scientists report finding fossils of dinosaurs in Antarctica's interior. Scientists have reported discovering the first set of dinosaur fossils ever to be found in the interior of Antarctica. The fossils are said to be the remains of a plant-eating dinosaur 25 to 30 feet long that lived about 200 million years ago. He needs to come to the seminar. The bones were spotted at a small section of exposed rock alongside the mountain, which lies about 400 miles from the South Pole. What's a dinosaur doing down there? How about this article? The discovery of thousands of well-preserved leaves in Antarctica has sparked a debate among geologists over whether the polar region, rather than being blanketed by a massive sheet of ice for millions of years, enjoyed a near-temperate climate as recently as 3 million years ago. In January, Mr. Webb, with David Harwood, an assistant professor of geology at University of Nebraska in Lincoln, and a couple other guys, found a deposit of leaves on the side of a cliff in a desolate stretch of the Transantarctic Mountains, which about 250 miles from the South Pole. The leaves, compressed by subsequent layers of ice, look like fossils, but unlike fossils which leave only mineral traces of the original organism, the leaves retain their original cellular structure. So these are simply pressed, preserved leaves. near the South Pole. At the North Pole, we have actually two North Poles. We have the magnetic North Pole, where your compass points, and your geographic North Pole, where the Earth spins around. I think they're about 800 miles apart. I don't remember the number, but it's something like that, roughly 800 miles. Now, if you live in Alaska, of course, there's quite a difference. You have to adjust your compass. When you get in your car and you think you're driving north, well, you're driving magnetic north. The compass is only pointing to magnetic north. Here in Florida, it doesn't matter because they both line up pretty well. So if your compass says north, well, you're still going north. Pretty close. Pilots, though, have to watch for this because the magnetic field of the Earth is a little irregular, and they will have to be adjusted, and they'll say, your compass is reading 8 degrees off. You know, pilots are constantly kept aware of that, you know, how to adjust their compass to be actually going true north. Otherwise, they'd be real lost in a hurry. Wouldn't land anywhere near where they're supposed to land. So I suspect the mammoths were up there chomping on their tropical flowers, and it began to snow. They'd never seen snow before. This was the fragments of ice coming in my theory. And so one of them said to the other one, he said, Herman, this is kind of peculiar weather we're having here. Let's get out of here. And he began to run around, you know, and the snow got deeper and deeper and deeper. And I know here we are in Florida, but how many of you have ever been in snow before? You ever been in snow so deep you could not fall over? You're just walking along and you stand there and you can't even fall down because you're stuck. Well, yeah, Wisconsin, you probably still got snow up there, don't you, in April? Yeah. I remember in June, going up to northern Michigan, and we could still walk out on the lake. It's frozen in June. Why does anybody live up there? I don't know. But these mammoths were probably chomping on their tropical flowers, and it began to snow. They got running around trying to find a place to escape this, you know, brand new disaster. They'd never seen anything like this before. And some of them ended up trapped in snowdrifts standing up. Snow buried them and suffocated them. You can suffocate in a hurry in a snowdrift. And they froze in a few hours. The Beresovka mammoth, in 1901, I believe it was found frozen, standing up. The wolves had eaten the trunk and some of the head and one of the front legs, but the rest of it was very intact and was taken back to, I believe they still have it in a big freezer in Russia someplace. Did you see this when you were in Russia, the Beresovka mammoth?
Yeah, I have heard of it.
You had not seen it, though. I think it's in Moscow, but I don't know. As the ice began scooting out toward the equator from this being dumped on the poles, it would carve out glaciers, or glaciers would carve out canyons. And all over the world you see mountains that are just obviously carved by glaciers, like the Matterhorn. Have you seen that one? They have a model in Disneyland. It's one of the Swiss Alps. The Matterhorn comes up and then goes back out and then goes up to a point. That's what makes it so hard to climb. You got to climb out to get going up again. So very difficult to climb the Matterhorn, they say. This is because glaciers went around it. It was a mountain. Glaciers went around it and carved out that place like this on the Matterhorn. Make a note for me to get a picture of the Matterhorn in here, would you, in slide number 158, I believe. Let's see. Yeah, after 158. And a lot of obvious glacial effects are found all over the world. There was an ice age. The question is, when? Okay, I don't think it was millions of years ago. If you go to Ohio, Kelly's Island is not too far from Toledo, Ohio. You can have to take a boat to get out to it. It's in Lake Erie. But you can go out to Kelly's Island, and you go all over Canada and see this feature right here. Glacial grooves, they're called. Scratches in the rock. If you took a great big huge rock the size of this house and dragged it across another big rock, it would leave scratches. Kind of like when you run your brake pads too low on your car, you know, it scratches the grooves in the rotors or in the drum. And this is what you have. These glacial grooves are found all over the world, in the polar regions primarily. These happen to be from Kelly's Island, Ohio. Those are among many other features that tell us, yes, there was an ice age. These black lines on here show the terminal moraine. Who remembers what a moraine is? Remember what a moraine is? We talk about that in here? As the ice is sliding along, it bulldozes in front of it piles of rocks. You might end up with a pile of rocks a half a mile high. Maybe not that high, but hundreds of feet high, okay? It'll pile up these rocks in front, And then the ice melts back. Well, the rocks aren't going to move. They stay there. And there are all over Illinois, Indiana, Wisconsin, Michigan, Minnesota is covered with obvious effects of an ice age because there's these piles of rocks. Now, over the last 4,000 years, a lot of dirt has blown in, and now there's trees built on. It looks like just a mountain, a hill. But if you dig down into it, it's full of big rocks. So, the Earth is totally covered by water. The cold spots on the North and South Pole, then, from this ice being dumped there, in my theory, would send out a cold wave. Like when you open the freezer, the cold air comes flowing out toward you. You can actually see the cold air flow out. The cold air moving off these polar ice caps would hit the warm air, causing it to rain. The canopy of water that used to protect them rained for 40 days and 40 nights. And all the sewers backed up, and everybody drowned. So this canopy is now gone, fell down at the time of the flood. Genesis 7. In the 600th year of Noah's life, in the second month, the 17th day of the month, the same day were all the fountains of the great deep broken up, and the windows of heaven were opened. And the rain was upon the earth 40 days and 40 nights. The flood water did not all come from the rain. I think the water for the flood came from three sources. Rain, 40 days and 40 nights. Be a good quiz question. Where did the water for the flood come from? Most of it came from inside the earth, right here. The fountains of the deep were broken up. It was subterranean water that simply came to the surface. If there was water underneath and all that water is put on top, the land then is going to sink down, and some pockets of water will be trapped. Some escape, some don't. And you end up with huge aquifers today. Oftentimes they'll drill down and drill into underground lakes. Massive amounts of water still trapped down in the ground. So the flood lasted a year. At least Noah was in the ark for a year. Probably the actual flood lasted 6 to 10 months. We don't know. But Noah didn't get out till a year after he got in. Here's the book of Jasher. How many have ever heard of the book of Jasher? Do we have that in the bookstore? Okay. This is not part of Scripture, but it is very interesting reading, okay? It's mentioned twice in the Bible. In Joshua 10, verse 13, and in 2 Samuel 1, verse 18, it says, is not this written in the book of Jasher? Well, where's Jasher? Okay, it's not in the Bible. Well, we have the book of Jasher if you want to buy it. I don't know the cost on it. Happen to know you're doing the catalog. It's $10, is it? Okay. Yeah, right there. $10. Okay, good. Thank you, Daniel. I need guys like you around here. Here's what the book of Jasher says. In Jasher 6:11. And on that day the Lord caused the whole earth to shake, and the sun darkened, and the foundations of the world raged, and the whole earth was moved violently, and the lightnings flashed, and the thunder roared, and all the foundations in the earth were broken up. Interesting. They were having some bad weather. Jasher is kind of retells the whole Bible story, Old Testament, just different perspective. Apparently not inspired of God, but inspired. Somebody was inspired to write it. Not of God, but just inspired to say, well, we ought to tell this story to the grandkids. And there's a lot of interesting things you can learn. Sort of like the Archko volume. Anybody heard of the Archko volume? A-R-C-H-K-O. Jan, you've got to read the Archko volume. I'll get it during the break. We'll take a break in a minute. I'll go get the Archko volume and show that to you. Matter of fact, we're on part 4, so it's a good time to take a break right here. Take a break. When we come back, we'll talk more about the flood.
Did you do the 3?
All right, let's take up here a little bit. We mentioned during the break we would try to get the book of Jasher. Just interesting reading, okay? If you like to read extra biblical history, the Archko volume, which I mentioned, is absolutely incredible. We don't sell it. We probably should. It is so good. This German scholar, 150 years ago, I don't remember the story now. It's been a couple years since I read it, but he got to thinking, if Jesus was such a famous person, surely there are some other records besides the Bible. He went back and searched ancient libraries all over the place and found interviews and court records about the life of Jesus that are not mentioned in Scripture. He tells all about how he discovered the records. Very fascinating story there. For instance, Jonathan was sent to interview the shepherds. This is the letter of Melcher, priest of the synagogue at Bethlehem, Sanhedrin 88b by R.J.O.S.E., order number 2. Jonathan, son of Heziel, questions the shepherds and others in Bethlehem in regard to the strange circumstances reported to have occurred there, and reports to this court. In obedience to your order, I met with 2 men who said they were shepherds and were watching their flocks near Bethlehem. They told me that while attending to their sheep, the night became cold and chilly, and some of them had made fires to warm themselves, and some of them laid down and were asleep. And they were awakened by those who were keeping watch with the questions, "What does all this mean? Behold, how light it is!" That when they were aroused, it was as light as day. But they knew it was not daylight, for it was only the 3rd watch. All at once the air seemed to be filled with human voices, saying, "Glory, glory, glory to the Most High God! And happy art thou, Bethlehem, for God hath fulfilled his promise to the fathers. In thy chambers is born the King, that shall rule in righteousness." Their shoutings would rise up in the heavens, and then sink down in mellow strains, and roll along at the foot of the mountains, and die away in the most soft and musical manner they had ever heard. Then it would begin again, high up in the heavens, in the very vaults of the sky, and descend in sweet and melodious strains, so that they could not refrain from shouting and weeping at the same time. It goes on page after page describing his interview with these shepherds and what they saw that night. That's just one of the chapters in here. That type of stuff, extra biblical. Very interesting. Pilate has a report here. The report of Caiaphas. Anyway, if you like that type of thing, we make a note. Let's check and see if we can get it through our bookstore and carry it here. In case I got enough stuff to carry on my table, and it's nothing to do with creation, evolution. It's just fascinating reading. If somebody sees the tape and wants to get it, we'll try to have it in our bookstore. There's another extra biblical book called the Book of Enoch. Now, there's a lot of serious questions about this one. Many people think that some Catholic Jesuit priests wrote this to justify purgatory and some other Catholic doctrines. The Bible does mention the Book of Enoch. I forget where it mentions it, but as it says in the Book of Enoch, just like it says about the Book of Jasher in Joshua chapter 10, it mentions Enoch. So I don't know if I'd put a lot of stock in this one. There are some real wild stories in here that obviously cannot possibly be true. About people living to be 9,000 years old or something like that. Or people being 900 feet tall. I forget what it was. Oral Roberts and his 900-foot Jesus. But the story may be indeed fabricated. There may be a real Book of Enoch someplace, and this may or may not be it. I doubt that it is, but we have one, and I'm not going to sell that. But if you want to take a look at the beginning, where to get one for yourself, and more extra biblical stuff. Okay, let's go back to the Hovind theory. So this ice meteor is coming in, breaks apart, fragments get dumped on the North and South Pole. That's why we have leaves there. That's why we have mammoths here, frozen, standing up, food in their stomach. Okay, the dump of ice on the Earth would cause the crust of the Earth to crack like an eggshell. This would release the fountains of the deep, and the ice would spread out, shoving out, dumping it here on the poles, pushing out toward the equator. Eventually it runs out of gas and stops. Glaciers will eventually stop, bulldozing ahead of it a pile of debris, which is going to become then a moraine once it melts back. This caused the burial of the mammoths. It caused the Earth to wobble for a few thousand years. Remember we talked about a spinning object that is hit by something? It'll wobble around, and then finally it'll stabilize. I suspect the Earth was more perpendicular to its orbit around the Sun as the Earth was spinning. Toward the east it goes. So if it got clobbered, the extra weight would cause the spinning Earth to wobble around. Today we're tilted over 23.5 degrees, still spinning, and wobbling a little bit, not much today.
Are the other planets more perpendicular in their...
They're all different. Yeah, some are real perpendicular. Uranus is 98 degrees tilted. It spins like that as it goes around the Sun. Venus spins backwards, real slow. I think it's 243 days, if I recall, for one day. Yeah, real slow, something like that. Plus their year is about the same. Maybe it's their day is longer than their year. I don't know. You can look it up in an earth science book. That I don't recall about it rolling on its axis. I know it's tilted. I think it's 98 degrees tilted over, if I recall. It's been 12 years since I taught this stuff. But I know where to find the information as it goes around, like so. Pluto apparently is spinning backwards. Venus is spinning backwards, and Uranus is spinning sideways. The other six are turning all the same way. Okay, so the Earth wobbled around for a few thousand years. The cold air made the canopy that used to protect the earth collapse, rain down, 40 days, 40 nights of rain, fountains of the deep squirting water up through the cracks, and everybody drowned. Earth was completely covered by water. The Bible says in Genesis chapter 7, "And the waters prevailed exceedingly upon the earth, and all the high hills that were under the whole heaven were covered." Now, I can't comprehend guys like Hugh Ross and ministries that would support Hugh Ross, but Hugh Ross says it was a local flood in the days of Noah. I don't see how you can read that verse and say it was a local flood. He says there's no reason for God to kill everything at the South Pole because there weren't any people there. Why kill the penguins? That's what Hugh Ross says. So Noah lived in the Mesopotamian area is what Hugh Ross says. Now how he knows that, I don't know. Mesopotamia is the region around the Black Sea or Iran, Iraq today. From Israel probably over to Iraq, Iran, maybe Afghanistan is called the Mesopotamian region. We know the ark landed there. That doesn't mean he took off from there. Does it? Let's say Noah's in the ark for a year. Let's just assume he was floating for at least 6 months. How far could you float in 6 months? Around the world? Twice, probably, right? There is absolutely no telling where he built the ark. There's no telling where the Garden of Eden was. After they got off the ark, they probably saw some rivers and said, "Wow, that looks like the river Euphrates." So they named it Euphrates. Doesn't mean it's the same river. People came from Hampshire to America and called it New Hampshire. It is not the same place, okay? And York and New York, and there's a lot of places like that here that are named after what reminded somebody of something else. Yeah, England and New England, there you go, sure. So it'd be silly to say, well, the Garden of Eden had to be over there in Baghdad, because that's where the river Euphrates is. Oh, come on, think about it, okay? It does not have, that does not mean that's where it was. The Garden of Eden is probably under 500 feet of mud someplace right now, buried in solid rock underneath Pensacola, Florida. Who knows? It could be anywhere. They landed right here. We have no idea where he took off from. But when the Bible says the earth, the water was above the mountains, all the high hills under the whole heaven were covered. Now, it doesn't mention mountains here. It says high hills. Later on, toward the end of the flood, it mentions mountains. Apparently, when God first made the earth, there weren't any giant mountains. The earth was smoother. Now, if you shrank the earth down to this size, 12 inches, all of the water in the oceans would be about that thick. I don't remember the number now, but it would fill 2 tablespoons. It would not even fill 2 tablespoons of all the oceans. It'd just be a thin coating, a little thicker than the paint on this globe. The crust of the earth, say a 20-mile crust on an 8,000-mile earth, you can figure it up, is not much at all. Very, very thin crust compared to the earth at this perspective. Okay. Pushing the mountains down and raising the bottom of the oceans up evens things out, and there's enough water to cover the earth about 1.5 miles deep. And 1.5 miles on an 8,000-mile scale compared to a 12-inch globe works out to be barely the thickness of the paint. Certainly not even, probably about the thickness of a piece of paper maybe on this globe. On these globes they put the mountains where you can feel the Rocky Mountains. Yeah, right. If you shrank it down to this size, you couldn't find Mount Everest with a good magnifying glass. Okay? You wouldn't notice it at all. It's nothing. So the high hills. Now Hugh Ross says it was just a local flood in Mesopotamia. Well, the reason he believes that is because he thinks the geologic column represents millions of years of Earth's history. So he has to protect the geologic column. Because if it was a worldwide flood, wouldn't that mess up all the geologic column? Well, yeah, so he don't want that. That's why he says it was a local flood in the days of Noah. And he's simply wrong. Hugh, you're wrong, okay? Get right with God on that topic. Okay. If the earth were reduced to this 12-inch globe like this one, all the waters in the oceans would not even fill 1 tablespoon. I knew I figured it out, the data here. Today, the oceans average 12,000 feet deep. If the earth were smooth, water would be 8,000 feet deep, 1.5 miles everywhere. The average height of the land, and here we are, 60 feet above sea level, right where I think my house is maybe 60 or 70 or 80 feet above sea level in Pensacola. The average height, if you took all of the mountains, Himalaya mountains, Rocky Mountains, all of them, if you averaged out all the land above sea level, it'd be 2,600 feet. Oceans average 12,000 feet deep. So if you draw that out on graph paper, 2,600 and 12,000, there's no comparison. There's plenty of water to flood the earth. Skeptics say, well, where do you get all the water to flood the world? Well, they're looking at it today thinking you have to cover Mount Everest. You don't have to cover Mount Everest. You have to push Mount Everest down, and everything gets covered. When they climbed Mount Everest, 1953, Edmund Hillary, first one that we know of, at least to get to the top, when they got to the 26,000 foot level, now Mount Everest is 29,028 feet tall. At about 26,000 feet, they began to find petrified clams, seashells. I've got buckets of them here in our museum. These petrified clams are interesting. They're closed. How many have been to the beach in Pensacola? You can walk along the beach and find seashells by the zillions, right? You hardly ever find a matched pair, and you never find them closed. If it dies, it opens. Very frequently, you find the seashells have a hole drilled in them. How many have seen that before? There's a special animal that grabs these clams and with his tongue, I believe, drills a hole, sucks the clam out involuntarily. And as soon as the clam dies, of course, the shell opens up. He relaxes. You very rarely find a matched pair, and you never find them closed if they're dead. And yet all over the world, petrified clams are found closed and petrified. What would that indicate? Buried alive or frozen. Probably buried alive. Underwater landslides. A clam doesn't appear to be too bright. When they panic or something's happening strange in their environment, they clam up. That's where the word comes from. Okay, they clam up. Shut the door till everything goes away, and then we'll see what happened. Okay. Well, if they all clam up and they get buried in a mudslide, they can't open. And they're going to petrify closed. I've got buckets of them here on the shelves. I will show you some later. In some places, they're 10 feet thick. A guy from Opp, Alabama, up the road here, how far is Opp? 120 miles, maybe? 150? Whatever. He called me one day and said, Brother Hovind, do you need some more petrified clams for your museum? I said, yeah. Why? Do you have some? He said, yeah, they're 4 feet thick in my backyard. Every time he rototills for his garden, he brings up thousands of petrified clams. We were in Texas in Glen Rose, seeing the footprints there, walking up and down the valleys and the hills around Glen Rose, Texas, and there are huge petrified clams closed in the middle of Texas near Dallas. Well, Dallas is a little ways from the beach, first of all, and these clams are huge. Of course, everything's bigger in Texas, you know how it goes. But they find these petrified clams literally all over the world. I have people give them to me. Also, we find fossilized eggs. Now, an egg is kind of fragile. To petrify an egg, you'd have to bury it quickly in nice, soft sediments that would later harden and preserve it. You can't be smashing these things around. And thousands of petrified eggs have been found. Genesis 7:11. In the 600th year of Noah's life, in the second month, the 17th day of the month, the same day were the fountains of the great deep broken up, and the windows of heaven were opened. I think the earth cracked open because it got hit. Cracks spread around the world like an eggshell or seams on a baseball, and the water came shooting to the surface. Being hit would cause it to wobble. While it was wobbling for a few thousand years, slowly wobbling, seasons would be a little erratic, and people would build temples to line up with whatever. And today the temples don't line up with the sun on summer solstice, the longest or shortest day of the year. Probably for several thousand. It's still wobbling some today. Well, if it got hit at the time of the flood, 4,400 years ago, and it wobbled for, say, 2,000 years, slowly the wobble would stabilize, like a gyroscope will slowly kind of stabilize.
What would the frequency of the wobble be?
Don't know. We heard last week when we talked about The Australian astronomer Dodwell, and the studies he did on the temples and how the Earth, he said it looks to him like something hit the Earth 4,350 years ago. That was his take on it, because of the wobble. Of course, the Earth is massive. I think it weighs 6 sextillion tons. So the wobble would be, you wouldn't notice it if you're on the Earth.
Each wavelength of the frequency.
Yeah, probably maybe a century or scores of years. You would not notice it. You'd probably go through colder winters for a while, and then more stabilized climate, and frequency of the wobble. Pick a number. 20 years, 50 years, 100 years. The Earth today still has cracks all over it. Mid-Atlantic Ridge here is a giant crack in the crust of the Earth. San Andreas Fault, the Golden Fault, the Hayward Fault. I've been to many of them. I think when the Earth broke open, though, the water inside would be warmer, maybe even hot. That water comes to the surface. Well, that's going to kill the diatoms. And I'll show you pictures of those in a minute. This is from Walt Brown's book. Now, he has a slightly different theory called the hydroplate theory. He does not buy the ice meteor idea. He doesn't think that's correct, and he doesn't think there was a canopy before the flood. He and I talked for some time. A real nice guy. When I was in Phoenix, Arizona at the airport, so I called him and said, hey, I got a 3-hour layover. Come on, I'll buy you lunch. So he came over and we had a wonderful time. And I love his book, In the Beginning. One of the best you'll find on creation. I would encourage everybody to read that, but he differs on this. He says the fountains of the deep broke open. The water came shooting to the surface from these subterranean water chambers. As the water came shooting up, the layer under, you got a layer of rock, layer of water, another layer underneath, which is actually a layer of basalt. Basalt is like lava, hardens into a substance called basalt. It's coming from a melted rock. That basalt would lift up in the crack, and the crack would get wider, and the crust would actually slide off, explaining why in some places of the world we find wrinkled mountains. These are up in British Columbia, Canada. If you take a piece of carpeting and start pushing it across the floor until you hit the wall, and you keep pushing, the carpet wrinkles, right? We find mountains that are obviously compressed from the end. These weren't just lifted up, they're compressed. If the crust of the Earth is sliding off of a rising mid-Atlantic ridge, it's sliding into what? I mean, it's not a vacuum out there. It has to eventually, something's crumbling. If the crust is moving anywhere, something else is either crushing or being subducted. Okay, it can't work any other way. In Yellowstone, of course, they have geysers shooting hot water up. I've been to all kinds of places where there's geysers in Calistoga, California, where they have Old Faithful. I don't know, probably 20 geysers are in the world named Old Faithful. Everybody has an Old Faithful. But are there any in Southern California, Daniel? Geysers or hot springs? Well, isn't 29?
Hot spring.
Yeah,
Calgary's got
that's right. They got one there
Rodeo Hot Spring.
at Murrieta Springs. That's right. Okay. That was cool. When at the top, it's like 120 degrees if you want to get in that spa, and as it goes down, it gets a little cooler. It was pretty slick. Oh, Chuck Smith did that. Anyway, these hot water coming out of the ground would kill the diatoms. Now, diatoms are gorgeous under the microscope, but you can't see them without a microscope. Okay, real tiny critters that live in the water. Their body is made of glass, silica. They are so tiny, when they die, they fall to the bottom, and you don't even notice them. The estimates are it may take about 1,000 years to get 1 inch of dead diatoms at the bottom of the ocean. They die, fall to the bottom, the kids die, fall to the bottom, the grandkids die and fall to the bottom. And you build up a layer of dead diatoms. Hey, Jeff, run out to building 4. When you first walk in the door, there are 2 boxes of diatomaceous earth. Bring that in, would you? Just grab one of them. One of them's open. You know what I'm talking about? It's a pretty good-sized box.
By the bathroom out there?
Well, yeah, right. 5 feet to Veronica's cleaning the building out. Walk in the door, go straight ahead 5 feet. You'll see it.
Okay.
So grab one of those, would you? Diatomaceous earth, you can buy it at the hardware store. We'll bring a box of it in here. Is used for all sorts of things. It's real cheap. It is so tiny, you can spread this stuff around your house, and bugs breathe it into their skin and kills them. It's a perfectly natural insecticide. I don't know of any bugs that can survive. There may be some, but I don't know of any that can survive diatomaceous earth. It's like extremely fine powder. When you feel this stuff, you just think it's like talcum powder or baby powder or something like that. You know, it's just real fine. It's actually these little tiny crystals, if you could see them under the microscope. And they're really gorgeous, all different shapes, you know, cubes and squares and diamonds and triangles. And diatomaceous earth is used for swimming pool filters. It's used for detergents to clean your clothes, for fertilizers, insulation, soundproofing, paper finishes. They will mix diatomaceous earth in with the slurry of wood chips and makes the paper have a slicker surface. When they make paper, diatomaceous earth in there. Soundproofing, oil dry, paint thickeners, the polishes, cat litter, you know, the white crystals you put out for the kitty, that's diatomaceous earth. Paint removers and scores of other things. In Lompoc, California, so how far did you live from Lompoc? 35, 40 minutes, yeah. Right on the San Andreas Fault. Yep. Welcome to Florida. Glad you're here. We get hurricanes here, but you can see them coming. The largest diatomaceous earth quarry in the world is in Lompoc, California. My understanding is they've been digging it there for quite a while. They think it may be 1,500 feet thick of this solid diatomaceous earth, which Jeff will bring in here if he can find it. You find one? Oh, look at that. Oh, hey, set that right up here. No, you don't need to bring both of them. Well, look at it here. Well, I'll bring the open one here. Yeah, we'll let the guys see what diatomaceous earth looks like. How much was this at the hardware store? I forget. Pool time. This is used for pool filters, but diatomaceous earth, get some out here. You can put it around your house for kill the bugs. Here, Nick, pass that around. Let everybody feel some of that. Very, very fine white powder. If you can see it under a good microscope. Hey, Daniel, by Marlissa's desk, up on the shelf up high, is a big block of diatomaceous earth, extremely fragile. Bring that in here, would you? Just, I mean, it's like packed talcum powder. I normally don't put that on display because it'll crumble in a hurry. But we'll get that here. When I was in Lompoc, California, several years ago, I toured this diatomaceous earth quarry. And they showed me how they dig this stuff out with bulldozers. I mean, it's 1,500 feet thick. And it's rock, but it's extremely soft rock, you know, much softer than chalk. You can just pick it up and just take it with your hand and just crush the rock, you know, to powder like this. Feels weird, doesn't it? Like real small. What happens is each of those crystals is so small, it absorbs a lot of water or liquid. They'll use this stuff for antacid. I believe that's what they use in antacid tablets, you know, because when you swallow it, the powder breaks apart and each little bit absorbs just simple surface tension, attracts a whole bunch of acid from your stomach. By the way, antacids are the wrong way to treat stomach acid, but that gets in a whole other subject in Bible and health. We'll get into that some other time. When I was there, Lompoc, California is just right smack on top of the San Andreas Fault. I think it runs right through the middle of the town. Matter of fact, the San Andreas Fault does. A diatomaceous earth quarry, Lompoc, California. Remarkable discovery was made during mining operations in 1976. Workers at the Dicalcite Division of Grefco Corporation uncovered the fossil skeleton of a baleen whale, along with trillions of fish fossils. The whale fossil is standing on end in the quarry and is about 80 feet long. Now, some have argued, well, yeah, but the layers are tilted also. I understand. Okay, so actually the 80 feet of whale is not the problem. It's the thickness of the whale, about 8 feet. That's the problem to explain. Apparently the whole area has tilted up since then. Jessica, can you see if he needs some help or if he fell off and broke his leg? We don't want to lose Daniel or my diatomaceous earth sample that I have there. You can have that, Jan. That's it. What would you guess that weighs?
4 pounds.
Very, very little, isn't it? This is what I got when I was there. This is diatomaceous earth, See the different layers? Yeah, the box right there, Nick, if you want to study it. This is extremely lightweight and very, very fragile. It contains probably 20 fish skeletons. Can you see those? They find fish packed in this diatomaceous earth literally by the trillions. He said, we dig through fossils here all the time. He said, when I was out there, I talked to the foreman. He said, man, about 6 months ago or something on the night shift, they were digging away this slab of diatomaceous. Now, they dig it out in layers kind of carefully because they grade it. Some's worth more than others, you know, depending how fine it is. Or sometimes there's impurities mixed with it. Obviously, this was deposited in a flood. But he said, we found the skeleton of a pterodactyl. It had a 60-foot wingspan. That would have been the biggest in the world. But we didn't tell anybody because as soon as you say, oh, we found a fossil, the museums and the universities say, oh, stop, let's come dig it out. What do you mean stop? We got 80 guys working here. Stop, as in, you know, let everybody stand around. So they generally just don't even stop production. They don't dare tell anybody we found a fossil because it'll stop production. They're there to make money by digging out this diatomaceous earth. They're not there to dig out a fossil. But they dig through fossils like crazy all the time. Very carefully, Nick, if you'd pass that around, let everybody feel that thing. Very, very lightweight. And the more we handle it, the smaller it gets. So we'll put it in the museum in a glass case and let everybody come look at it. But sorry, you won't be able to touch that one normally. You could probably be the last ones to get to touch it because we got our glass shelves up today. So the thickness of this whale becomes a problem. Let's assume it does take 1,000 years to get an inch of diatoms. Wouldn't the whale rot before he was covered up? How could an 80-foot long whale, say 8 or 10 feet thick, get preserved in solid diatomaceous earth? Well, apparently the diatoms formed very quickly. The layers formed very quickly in order to preserve the whale. Wouldn't it preserve him otherwise, would it? Here's that block of stuff you're holding in your hand there. And it's all rubbing off on you, and that's the diatomaceous earth, okay? I mean, they dig it out by the trainload. Unbelievable amounts of that stuff. I mean, massive bulldozers come in there. Yeah, worse than chalk. It's actually finer than chalk. It gets down in your pores. Very weird stuff. But there's probably, we could count them, but it'd be tough to count, I guess, probably 20 fish fossils. Daniel's going to count them. Over 20, yeah. Just in probably 1 square foot. And this way for several miles. Literally trillions of fish perished, okay? In Dover, England, the cliffs are chalk. Matter of fact, in Latin, the word Cretia means chalk. So the Cretaceous age that the kids learn in their geologic column was named after the layer of chalk found in England and over in France. Cretaceous for Cretia means chalk. There's so much chalk, the evolutionists call this the Cretaceous age, the age of chalk. They have solid chalk, just like you write on the chalkboard with, 300 feet thick. You can break up your yard and write on the chalkboard. Well, chalk is obviously made from marine organisms. So how do you get so much, how many marine organisms would have to die to make a 300-foot thick layer of chalk? It's called calcite. The chalk cliffs of Dover, made of calcite. Genesis 7. The Bible says, the waters prevailed and increased greatly upon the earth, and the ark went upon the face of the waters. See, the waters prevailed. They had the power over the earth there for a while. I think during the first few months of the flood, the dead animals would settle out. The hot water coming out along these cracks is going to kill the diatoms by the zillions. If you poured a gallon of boiling water into an aquarium, what would happen to the fishies? Well, within a certain effective radius, it's going to kill them, right? If they happen to be far enough away, it won't hurt them. But if they're too close to where the boiling water contacts, the temperature rise is too quick and it kills them. I think the diatoms all died within several miles of the San Andreas Fault. And instead of slowly accumulating at the bottom, they all died at the same time. and you got a 1,000-foot thick layer of dead diatoms in a few weeks, preserving trillions of fish and all sorts of other things too found there. These dead animals settle out. The swirling waters, though, deposit piles. You can get water swirling in a pond, and it's really neat the way it separates things on the bottom of the pond. You get gravels to the middle and then sands. It makes concentric rings. Coal would form then, and fossil graveyards over the next few hundred years. Moving water automatically sorts particles based upon their density, based upon a lot of different things, actually. Have you seen those things, the two pieces of glass with different color sand inside? You flip it over, and you got those, right? It's your place, right? Makes all sorts of pretty patterns. Jessica, put on the list to, let's get 3 or 4 of those for the museum for the kids to play with, small ones. You can buy those at the mall. Where? No, 2 pieces of glass with sand and water in between, different color sand. You flip it over, and when it comes down, it makes these different patterns. It automatically separates. Why does it do that? Well, that's just a phenomena of particles falling through water. The denser and lighter are sorted. So some people look at the geologic column of the earth and say, well, this took millions of years for each layer. No, this took one flood for all of the layers. It's a matter of looking at it from God's perspective. Underwater landslides can happen. They're called a turbidity current. They do enormous amounts of damage. Scientists are really shocked at how far mud can slide underwater. There was an underwater landslide that cut the transatlantic cable. The mudslide was going 70 miles an hour underwater. Fastest sub, probably 30, 35 miles an hour. 70 miles an hour. Cut off the transatlantic cable. Okay, swirling waters are going to deposit animals in fossil graveyards. And we'll quit here in a second. The animals, as they float around for a year or 6 months, would rot. You'd get huge eddies of swirling, rotting carcasses, trees, grass, mixture of everything in this muddy water in the flood. Now, it wouldn't be all turbulent all the time, every square inch of the earth, okay? I'm sure there's probably storms going on right now on the earth. It's not affecting us, is it? There's probably typhoons and hurricanes hitting someplace right now. It doesn't affect us. And when one hits us, it doesn't affect the folks in China. So people say, well, if the flood was so turbulent, how did Noah survive? It'd break the boat apart. Well, duh. Just because it's turbulent one place doesn't mean it's turbulent every place, okay? As these animals rot, they're going to become what's called disarticulated. The bones are going to come loose from each other. And they're going to end up buried in tangled up messes. Notice the dinosaur backbone here. There's no legs, no ribs, no head, just the backbone. And, importantly, no teeth marks. Look at the one above the guy's head here. You see the backbone is bent backwards? These animals were rotting in water before they were buried. If they were being torn apart by scavengers, you would have teeth marks on the bones. You don't. And we'll take that up next class about continuing on the Hovind theory. If you can hang on that long or fast forward the tape, if you're watching the tape, we'll get there next time. Thank you so much.